University. Prof, you're welcome. I'm happy to see you here today. Prof Mabizela is a professor of mathematics, my former boss, because he appointed me. And the reason why I'm going on and on is because I have to pay my dues. He's the one who appointed me. I'm conflicted, colleagues. You're welcome, Prof. You're welcome. Distinguished keynote speakers, esteemed panelists, colleagues, valued stakeholders, Umalusi executive and senior management, and the hardworking staff of Umalusi. Ladies and gentlemen, it is my pleasure to welcome you to this important seminar convened by Umalusi under the theme Unpacking Mathematics versus Mathematical Literacy Enigma in South African Schools. I would like to thank all of you for making the time to be part of what we believe is a necessary, timely, and substantive conversation about learner pathways, curriculum purpose, and assessment in our schooling system. As a Quality Council for General and Further Education and Training, Umalusi is mandated not only to assure the quality of qualifications and assessments, but also to contribute to evidence-based dialogue on issues that shape educational outcomes and equity. Today's seminar forms part of our broader thought leadership agenda, one that seeks to move beyond polarized debates and towards an informed, data-driven, and contextually grounded understanding. Few issues in South African schooling evoke as much contention, misunderstanding, and consequence as the perceived divide between mathematics and mathematical literacy. These subjects are often framed in hierarchical terms, one viewed as rigorous and prestigious, and the other as a lesser alternative. Yet such binaries obscure the complex policy intentions, curriculum design, learner aspirations, and systemic constraints that give rise to the introduction of mathematical literacy and continue to shape learner choices today. At the heart of this discussion are critical questions. What was the original rationale for mathematical literacy, both in South Africa and internationally? That is the question we have to ask. Another question that we have to ask is, how do learners come to be channeled into mathematics or mathematical literacy, and what role do schools, parents, and systemic pressures play in these decisions? Another question, what does the data tell us? And equally, what does it not tell us about performance, access, progression, and post-school opportunities? We are privileged today to hear from Professor Mark North, who comes from the UK, but I realized that he grew up in South Africa, and I want to say welcome home, Professor North, who will reflect on the historical and international perspectives that informed the development of mathematical literacy, grounding our discussions in both policy intent and comparative practice. This will be followed by a data-focused presentation from Dr. Stephen Taylor, who will interrogate patterns in learner choices and outcomes and caution us against simplistic interpretations of performance statistics. Later in the program, our panel, capably moderated by Professor Mary Metcalf, will bring together voices from academia, government, civil society, and the private sector. I'm at this stage going to acknowledge Dr. Lynn Bowie, Professor Rajendran Govender, Me Nkwinika, and Mr. Matsaum Thabo Hollo for their willingness also to engage frankly with both the possibilities and limitations of our current approaches. What we hope will emerge from today's discussions is not a defense of one subject over another, but a more nuanced appreciation of purpose, alignment, and consequence. If mathematical literacy is to be meaningful, it must be understood in its own terms, not as a proxy for failure in mathematics, but as a specific subject with defined outcomes, real-world relevance, and specific progression pathways. At the same time, we must confront hard questions about whether current practices genuinely expand opportunity or inadvertently reproduce inequality. Umalusi does not claim to have all the answers. However, we are committed to fostering spaces such as this, where evidence is interrogated, assumptions are challenged, and policy conversations are enriched by multiple perspectives. The insights generated here will inform our ongoing research, quality assurance work, and engagement with stakeholders across the system. I encourage all participants to engage openly, respectfully, and critically throughout the day. Colleagues, let us use this opportunity not only to interrogate the enigma before us, but also to consider how our collective decisions can better serve learners and the broader goals of social and economic development. With these words, I formally welcome you to the seminar and wish you a productive and thought-provoking day. I thank you. Thank you for listening to me.
Thank you very much. Thank you very much, Dr. Rakumetsi, for the encouraging opening words. I will now call on our first keynote speaker. Also just want to set some rules for the keynote. We will have a discussion on both keynote speakers after the presentations. Right? We have a fairly large number of attendees today. Right? So we rather sort of keep questions and sort of suggestions for the discussion. Should you, however, have questions of clarification, right? I think that we can allow potentially during, but preferably after each individual keynote speaker's presentation. Right? With that, we will start with Professor Mark North. Professor Mark North is an expert in mathematical literacy, not just in terms of South Africa, but also internationally. He's a professor of education at the University of Nottingham, who has extensive teaching experience in South Africa as a mathematics and mathematics literacy teacher as well. He has written a number of documents on mathematical literacy. He also authored the Mathematical Literacy CAPS document for the Department of Basic Education, which then was used as a training document for the rollout of mathematical literacy. He acted and served as a national examiner for mathematical literacy for the IEB. And I think his experience over the various years and his research makes him an excellent speaker for today's seminar. He will speak on the history and rationale for mathematical literacy in schools, South Africa, and international practices. Please welcome with me, Professor Mark North.
Morning, everybody. I'm probably going to end up being a corker. I wonder. Don't stand still. So we'll see what happens. I'm not sure if we'll see how far I can go with it. So first of all, just to say thank you very much to Dr. Umalusi for the sort of introduction, and to Volker for the bio. Thank you very much to Umalusi for making it possible for me to be here. When they emailed me and they said, Mark, would you consider coming to do this? I said, hell yes, of course I would. I'll be on a plane tomorrow if you'd like me to do that. This is clearly not a British accent. And as Dr. Umalusi was saying, as soon as I land in Johannesburg, it was like I'd arrived back home. And this is very much, I feel very much at home. And I feel very much like this group of people are my people. So thank you very much for the opportunity to do that. Is somebody going to control the slides for me? Is that what will happen? Amazing. If somebody has a clicker, then we'll see what we can do. Is somebody going to control the slides, or do you have a little piece of tech that I can use? Amazing. It's okay. I think we've just got a technical change in batteries, but I'm sure we'll be back on track in a moment. But in the meantime, I'll keep talking and somebody can just change it manually for a minute. So if you wouldn't mind just flipping over to the next slide. I am currently based at the University of Nottingham. I've been in England for about 10 or so years now. And I'll give you a little bit of background about sort of my roles and responsibilities there. But my actual reasons for coming here, if you can click, that would be great. Thank you. Just click ahead. Because that's the temperature at home at the moment. And if you click the next slide, it has rained every single day since Christmas Day. I kid you not, every day. So this is the first time I've seen sunshine in about 2 months. So I'm really grateful for being here. And then if you click the next, please. Just one back. One back if you don't mind. Thank you. I'm really tired of seeing geese. Those are the only animals I see. And so I was super excited to see some alternative animals. Next slide, thank you. I just want to give you a little bit of background. So that was me. I grew up in KZN, and then I studied at UCT, and then I went back to KZN and worked in KZN for a number of years. I don't care what anyone says. I was rocking boots and shorts back in the day. But what I really want you to take note of is my mathematics grade at matric, D. I think the only reason I passed was because they standardized the results that year. And I picked up. I absolutely hated mathematics at school. It made no sense to me. I can remember sitting in class thinking, I do not understand what you're talking about. I do not have a clue. And then, so I went to university to do history and politics. And somebody said to me one day, if you want to become a maths teacher, if you want to get a job as a teacher, rather take maths because you will always need maths teachers. So I picked it up late. And I did my first year in maths and got a distinction. And I thought, okay, well, that was a fluke. Let me try that again. And I did my second year and the same thing happened. And I couldn't quite figure out what was going on. And I think a lot of reflection has allowed me to understand that it's actually about, because most of the maths I was doing at university was applied, so it had relevance and it had meaning. And so I could see the purpose behind what I was doing. And so suddenly it made sense. Whereas at school, it never made sense because it always felt disconnected from my lived experience. So, and that's really, I suppose, where my passion for mathematical literacy has come from. I'm 100% a believer in the qualification. I absolutely believe it has an essential role to play. And I acknowledge that there are some challenges around its implementation and how it fits within the qualifications framework. But I need you to know that I'm definitely standing here and I'm more than happy to take any critique and any criticisms about it. But I 100% believe that it is the right thing for many, many, many students. If you wouldn't mind just flipping to the next page, please. Next slide. Amazing. I taught for a number of years, and then I was working with teachers at the same time that I was writing the mathematical literacy caps. I was working with teachers and students in very rural schools in KwaZulu-Natal. So, and that again has really informed. I hope that you will see it's informed. Thank you. It's amazing. Thank you. Just right. Yeah, that's working. Amazing. That was really formative for helping me to think about the purpose of mathematical literacy and also the students that would be engaging with the mathematical literacy curriculum. And that gives an example of some of the context that I was working in. So yes, I was the author of the CAPS, the Mathematical Literacy CAPS document, and I know that Elspeth Campbell is in the audience. It was thanks to her, she recruited me into that, and then just said to me, Mark, just do what you want. There's no rules, just do what you want. So I did what I wanted, and anyway. Okay. So just my current role, I've obviously gone over to the UK, and I now work across a range of spaces. I spend some of my week in grade R classrooms, singing songs with children and letting them wipe snot on my trousers, because that's what they do. And then I also spend some of my time in primary school classrooms and then also in secondary school classrooms. So at the moment, I currently, and this is maths focused, not mathematical literacy, because they don't have that in England in the same way. But I work across the entire education system, the schooling system at the moment. And then my other role is that I work with primary PGCE students and secondary maths PGCE students. So I'm supporting the development of sort of training teachers really in terms of that. And then I do some work which is about training and professional development for in-service teachers. So you can see my heart is very much in the classroom. I love spending time in the classroom. I love singing songs with the littlies. They're absolutely fantastic. Okay, and then you get to secondary school, and they're not so nice anymore. They don't like maths in the same way as they do in grade R. But anyway, there are reasons for that. I've also been carrying on and doing some work with colleagues in South Africa. So I was here in February last year, and we're doing some work in Bronckhorstspruit with some schools and some subject advisors, some teachers in that area. And we've got ongoing collaborations going with colleagues at WITS and UKZN, and hopefully in the future at UP as well. But also just the other reason why I'm here is because I think as South Africans, we sometimes think everything is so bad and it's always better everywhere else. And I always notice that when I arrive back in South Africa, and as soon as you're standing in the queue to get through passport control, everyone's complaining about the length of the queues. I promise you that the queues are much longer in England. So stop complaining about the passport control queues. The red line is the pass rate. And I just want you to get a sense of, so this is GCSE, so this is up to the equivalent of, this would be grade 10. That's the exit point in England. And I just want you to take notes of the figures, the number of students that are failing mathematics. And so grade 3 and below would be a fail. The problem is not unique to South Africa. There are hundreds of thousands of students across the world that do not cope with the demands of the mathematics curriculum. And then the question becomes, so what do we do with those students? So what they do with them in England, which I actually think is a bit of a punishment, is they make them keep rewriting until they pass. So some students will do their GCSE reset exams 3, 4, 5 times. And you can imagine these students don't like maths, but they have to pass. And then often a number of these students who don't get GCSEs will go into the further education sector, and they'll be doing vocational courses, and then they can't complete their vocational training because they don't have their GCSE reset yet. So this is a much bigger problem internationally. It's not just about South Africa. And also the other reason why I'm here hoping to share some positivity with you about the South African situation is that even in places like England, Australia, New Zealand, many countries in the global north, they have significant issues with adult numeracy, which then affects financial literacy, and of course that affects productivity in the economy, and it means people are getting into debt, and so on and so on and so on. So a lot of the issues that we are experiencing here, and a lot of the issues that mathematical literacy was brought in to address, other countries are experiencing in the same way. So it's just worth bearing that in mind, I think, when we feel a bit disillusioned about things. So just in terms of my sort of aims for the presentation, and I just want to make sure that I can see here. The first aim is, let me just get onto this thing. Yeah. So the first aim is just to explore where did the mathematical literacy curriculum come from, and what are its intentions and its aims. I'm going to argue a case for the importance of mathematical literacy, both in South Africa and internationally. I'm going to try and explore and understand some current tensions and contradictions in the subject. We know that they're there. And then the last one is, of course, just to spend time with people from the best country in the world in the sunshine. Right, so we're already doing that. So just thinking about the presentation focus, there is an article that I wrote a little while ago, which you're welcome to have a look at. Does this microphone work if I switch it on? Or
Yes.
it does. And then do I just switch? Just can you hear me?
Yes.
Yes, you can. So can I'm feeling a bit stuck here. Just switch this one off. It's amazing. Let me walk here. There, I feel much better now. Can you still hear me? Is that okay? Amazing. I feel much better. Once a teacher, always a teacher. Okay. So that just gives you a sense of the of what I'm going to be talking about. We're going to do a bit of maths now, so get yourself ready. You always do maths in a session with me. We are not sure. Oh, it is not. Yeah, it's very soft. I don't know if you can turn it up. Apologies. While he's doing that, I'll just speak with my teacher voice. We're going to look at the maths curriculum structures in South Africa. We're going to look at some curriculum design principles. Oh, fantastic. Thank you. Oh, that's much better. We're going to look at the CAPS specifically and this idea of a life preparation for empowered and empowered citizenship agenda. We're going to look at some contradictions and challenges, and then I'm going to just make an encouragement going forward. Okay. So some maths for you, please. I'd like you all to factorize that. Have a go. Factorize that. Taking you back now. Taking you back. Taking you back. There's some shocked faces in the audience thinking, I never signed up to do maths. That wasn't advertised. Oh, listen. Okay. Somebody's got their hand up. Have you got an answer for us, sir? Oh, ma'am. Wow, x minus 2, x minus 1. Okay, fantastic. Someone saying no. Yeah, this wasn't the plan. We weren't meant to have an argument. Yes, ma'am. Yes. Right. So we've created the division between the maths lits and the maths now, haven't we? Fantastic. Okay. Let's just ignore the answer. The answer is not important, right? The mathematicians are now going crazy. So he's saying the answer is not important. What are you talking about? What I'd like to know from you now, the next thing I'd like to know is what might this equation represent in real life? We teach this. We spend hours and months teaching this to our students. So what is this? Well, where do we use this in real life? Come on, those of you that are teachers. Yes. Amazing. So that would be one application. And I'm going to show you a couple of others. Thank you for that. Now, I'm going to show you a couple of others. Of course, when we go shopping and buy bananas, we always use quadratic equations to work out the slope of the bananas that we're buying. So when you're diving into a swimming pool, that's the first thing that's going through your head. It's not the water, it's what the quadratic function is that's modeling my. And of course, when we were watching football on the weekend, that's exactly what we're thinking about, isn't it? Now, this is a bit of a stretch. So my son, his maths is just amazing. Anyway, and he's just finished his degree in electronic engineering. So I said to him, now you've got to understand, he's an engineer. So when you ask him to explain something, you've got to sit down for half an hour while he explains it to you, because that's what engineers do. And so at the end of half an hour, I said to him, right, Josh, you need to give me a 30-second summary. Yeah, sorry, that's just, I don't know what's happened. Don't think I switched. Did I switch it off? No, I don't think I switched it off. Apologies. Let me try that one. Stephen, I'm going to iron out all the technical issues before you arrive. That's amazing. Thank you. Okay. And so 30-second summary, and then I said to him, can you actually just send me something with an explanation so that I can make sense of it? So this is what he sent to me. Yeah, okay. So he's got his master's in electronic engineering now, and so electronic is all the stuff in the phones and the cars and whatever else. And so he was talking about 0 points. He was trying to explain to this idea of 0 points. And man, what you're talking about, the 0 points are kind of the intersection points. And so I said to him, no, okay, I really don't understand what's going on here, even though I teach maths. So I said to him, can you send me a video? So he sent me this. Let's see if we can get it to work. Changing. Oh, there we go. Right. Can you just, you may have to press play on that video for me.
Right, yeah, this should hopefully be a lot simpler than the ones I
Now we found going.
showed you earlier, because I'll stop using them.
So if we just take it back a step, what is these three equations at the bottom? And he's talking about the poles of the system here. The poles. If one is negative and one's positive, that's where you get this happening. Yeah, Lord. If both are negative, then what you end up with a stable system. So it's interesting, isn't it, that we teach this stuff, but we don't really understand what happens with it. And it's only in fourth year electronic engineering at university that they actually start putting this stuff into action. So I'm not suggesting quadratics aren't important. What I'm asking you is, do all students need to be doing quadratics? Okay, so some people are saying yes, some people are saying no. So, and hopefully that'll kind of ignite a bit of debate a bit later on. Okay, thank you. Let's see if I can. All right, that's his voice in the background. Let's go to the next slide. Thank you. All right, I'd like you to just have another look at this one quickly. Maybe just have a 2-minute conversation with the person next to you about what's going on here. Okay, I'm sorry to interrupt you. Okay, I'm sorry. Fine. Okay, I'm sorry to interrupt you. Has anybody figured out the trick? Anybody figured out the trick? What's the trick? Not just an even number or an odd number, but it's a specific numbers. What do you mean? Somebody said 4. Oh, are you adding the maximums? Good. So as long as you can, but there is a trick here. I'm not going to go into it because yes, sir. Allow the other person to start first, and then. Okay, so you keep adding 4, and then add 3, and then around. So, but there is a trick here. Now, my question is, it was interesting because when I gave you the quadratics, a lot of people were like, "Hi, Paul, what's going on here? This is not actually." And now I gave you this, and everybody was engaging. So how is so? And the other thing, of course, is there's actually quite a lot of high-level reasoning happening here. But the maths is accessible, and I think the point I want to make is just because the maths isn't high level doesn't mean there isn't high-level reasoning happening. Okay, so just to make that point. And then I want to show you this, because this is more closer to a mathematical literacy scenario. And this one, I was hoping to have access to a computer for this, but I'm trying to think. There is a spreadsheet model that goes with this. Which computer is it on? Is it on that other one? Yeah, can you just click on that spreadsheet and see if it opens up? Click on the link where it says Microsoft Excel. Okay. Yeah, can you drag that onto the screen? I'll have to exit out of this one. Let's just see if they can get the spreadsheet up. Okay, thank you. That's great. The graphs have disappeared. I'm not sure why. It's because it's opening it in. All right. What I'll do is I'll have to connect on my laptop just now and show you. So for now, but basically, if we want to think about mathematical literacy, the core of mathematical literacy, I would argue that mathematical literacy is all about solving problems. But in order to solve problems in the real world, you have to be able to generate mathematical models. You have to be, you can't understand problems if you can't generate models that enable you to understand the problem. And for me, that's the missing dimension of mathematical literacy at the moment. Is it's focusing on the calculation, it's focusing on the problem solving, but you can't do genuine real world applications without modeling. And also notice that the example that my son gave you, that's all modeling. It's just modeling with abstract mathematics rather than with simpler real world applications of mathematics or real world mathematics. Okay. So if you actually think about a mathematical literacy in its pure state, is as complex as mathematics, but you're doing something different. The maths isn't high level, but the modeling and the problem solving and the reasoning that you're doing is high level. Okay, so we need to maybe shift our thinking around when we talk about high level reasoning, what does that mean? In mathematics, it might mean something different to what it might mean in mathematical literacy. Thank you. If you go back into the presentation, please. Thank you. I'll just, if you get it up, I'll scan, I'll zoom forward. Right. Okay. So what's the point of all of this? Well, the point is that when we solve problems in the real world, something different happens. The maths is fairly simple for the most part in the real world, unless you're doing like really technical, complex stuff like my son. But knowing how to model problems and what tools to use is difficult. Competencies are foregrounded over knowledge. Often it's about skills. You can learn the knowledge while you're doing something, but it's about having the skill to know what to do with the knowledge. That's important. Maths is only one of several tools that people use. It's not the only tool, and often it's not the most important tool. Okay? The maths is a means to an end. In other words, we solve problems and we make decisions. The maths enables us to do that. In mathematics classrooms, the maths is the means to an end. We're learning the maths. That's not what's happening in mathematical. Well, perhaps shouldn't be what's happening in mathematical literacy. And I'm talking about an ideal case scenario here. Technology plays a vital role, and I know there's some challenges around the use of technology. But then also reasoning and reflecting critically and communication skills are absolutely vital. So it's not just about getting an answer and about the answer being correct. It's about, can you explain and help other people to understand that? Okay. So just a distinction I want to make here between using maths in the real world and using maths context in the maths classroom. When we use maths in the real world, what we do is, let's start with this one. When we use context in the maths classroom, what we do is we borrow the context from the real world and then we change them to make the mathematics the center, to foreground the mathematics. When we're solving problems in the real world, something's different. What we do is we pull tools from the mathematical world that enable us to make sense of the real world. So we've got a different direction of movement happening here in terms of the relationship between real world and mathematics. Okay. Okay, so let's just have a look. We all know this. This is the current maths provision. So we've got mathematical literacy and mathematics, but up until end of grade 9, maths is compulsory for all. And just to remind you, but sometimes we forget this, the reason why mathematical literacy was introduced was to target the 40% of the population who opted out of mathematical study. Okay, so you can argue that mathematical literacy is stealing people away from maths and etc. But just remember that there was a time where we had at least 40% of the school-leaving population that were doing no mathematics in the FET phase. And of those that were doing mathematics, large proportions of them were failing. So, and then obviously we've got core maths, so we've got compulsory mathematics. Now, you know this, Jonathan Johnson, he's not my friend. He doesn't like this subject, but that's okay. And he's been quite incredibly vocal about the subject. So there are some challenges and some provisions. I just want to highlight this. I know Stephen's going to do that. I think this is where this is 2003 data, so it's slightly dated, but the trends still apply. I think this is the important part. that if you look at the sort of the percent achieved at 30% in 2023, 82% versus 63%, 82% maths, that's 63% in mathematics. And then the numbers of students who are writing is obviously, it's almost double. So that's the issue. That's been one of the key criteria. You don't often see this data recorded. And I'll let you have a look at that. Couldn't find the data for that missing block, but it's not in the technical report. So that's interesting, isn't it? That more students are getting A's in maths than they are, a high proportion of students are getting A's in maths than they are in mathematical literacy. So we always quote the pass rate data. What we don't quote is what happens in the interim. And actually there's an evening out as you move from the pass rate and you move through the different grade levels, there's an evening out of percentages of students at each of the different levels. Okay, so it's worth thinking about. So mathematical literacy actually is harder to do well in. Very good reason for that, it's the language issue. The reading comprehension and language issue. Okay. But what I want to just focus in on, because I think this is where, what's my timing? 15, that's great. So I just want to start to think about why is it possible to criticize mathematical literacy as a second-rate or watered-down subject? I want to kind of get to the core of that, because it was that question that really informed the development of the CAPS. And I want to start by talking about different curriculum levels. So, and many of you will be familiar with this. You've got the intended curriculum, which is kind of, it embodies the social ideas, political vision, etc. So that's where our curriculum documents would fit. You've got the implemented curriculum, that is about sort of teachers, what teachers do with it and publishers do with it, how they interpret the intended curriculum. And then you've got the assessed curriculum, and that's obviously the curriculum that's actually assessed, which is not always the same as what was in the curriculum document. It might be a selection of, and it's also not necessarily the same as what's being taught in classes. So, and that would be the exams. And then there's also this, and this doesn't always feature as prevalently, there's something called the attained curriculum. That's what the students actually learn. And just because we're assessing them doesn't mean they're learning what we think they're learning. And any good teacher will know that. You spend a whole lesson teaching something and you ask the students, what did you learn at the end of it? And they tell you, oh, well, you wear really nice clothes. That's what they've learned about today's lesson. Okay. So, and that it's actually the attained curriculum that then informs what comes next. Where they go in terms of study and how well they perform at higher education or in the workplace, etc. So it's just important to keep that in mind. Okay. And so what I want to, and I also just want to just deviate, and I'm going to talk a little bit about Bernstein stuff, not in detail because the stuff is just so complex. But what Bernstein talks about is that actually sometimes we think that education is a vehicle for sort of leveling out, but actually what Bernstein talks about is that education actually is imbued with disadvantage, and different students have access to different opportunities. And even, you know, and if you want to think about it at a basic level, the assessment system is a filtering system. So it tells students who can and can't do certain things, okay? And I'll just read this. If we look at the knowledge school transmits, we shall find that it's based on a distributive principle such that different knowledges and their possibilities are differentially distributed to different social groups. Think about maths lit and who does maths lit versus who does mathematics, and the higher status perhaps that mathematics has in the framework than mathematical literacy, etc. And there's distribution of different knowledges and possibilities, not based on neutral differences in knowledge, but on a distribution of knowledge which carries unequal value, power, and potential. And Bernstein then talks about something called the pedagogic device. I don't want us to get caught up in the nuances of all this very theoretical, technical language. But it describes this process by which knowledge is not neutral, that somebody is making decisions about which knowledge informs our curriculum and who that goes to. And this is a very, very complicated diagram. Don't try and make sense of it. But the colored parts, the shaded parts, what's happening? The shaded parts are the parts that you need to focus on. So somebody somewhere in the world decides what counts as valid mathematical knowledge. This is like internationally. So PISA and TIMSS have had a significant influence on what countries consider to be appropriate or valid mathematical knowledge. So that's in the field of production. And then what happens is somebody in South Africa decides in the basic Department of Education, we're going to take selections from the field of mathematics and we're going to turn that into a curriculum document. So there's a recontextualization that happens. And that recontextualization doesn't always match what the original, it's a revised version of that's drawn from the knowledge, the sort of the field of production. And so what we've ended up with in South Africa, we've ended up with these two subjects called mathematics and mathematical literacy that are a combination of mathematics, but also of mathematics education. Because there's stuff about teaching and learning is not unique to mathematics. So there's two things that are influencing these two curricula in South Africa. The one is mathematics, but the other is mathematics education. And then this is again the important part. Then you've got this evaluation phase. And this is about teachers and schools have to try and recognize what the curriculum, what counts as the valid curriculum, and help the students to realize that in their lessons. So what counts as valid knowledge in history is not the same as in mathematics. It's not the same as in geography. There might be some overlaps, but the realization and recognition rules, the evaluation rules are different in those subjects. And I'm going to just come back, I'm just introducing this at a very broad level, because I'm going to use some of these concepts a little bit later. So let's look at, this was, you will be familiar with these. This is the intended maths, lit, and mathematical literacy curriculum, and I'm going to simplify that by basically saying, in mathematics, the end goal is understanding of abstract mathematical contents and apprenticeship into mathematical ways of working. And yes, there might be some problem solving involved, but the focus is we want people to develop enough mathematical understanding and knowledge to be able to pursue mathematically related areas of study and work. In mathematical literacy, I would argue that the end goal is something different. The end goal is that we should be able to use a combination of tools, some of which are mathematical, some of which are not, some might be technological, some might be other resources, in order to solve problems and make informed decisions that people might encounter in their daily life. So the end goals of the subjects are completely different. So how we get there needs to be different. Okay? So if you want to think about it in a different way, in terms of Bernstein's language, the realization and recognition rules, the evaluation rules are different. They're not the same. So we shouldn't be saying mathematical literacy is the second cousin of mathematics, or it's a lower form of mathematics, because they have completely different end goals. Okay. So this is, but there were some contradictions, because if you look at that from the NCS curriculum, thank you, you can see it just looks like the mathematics, a statement from the mathematics curriculum. So even though it was designed to be different, the way that it's been implemented, intended in terms of even at the curriculum level, it's been problematic in terms of the way in which mathematics is foregrounded. And then a whole range of people have talked about this through the research. You can have a look at those, but it's about the fact that, will the subject actually create a livelihood gaze, or will it just give you a mathematical gaze? Because if mathematics is foreground, it's not really going to help you to make sense of the real world, because the real world is not like the mathematics classroom, it's completely different. Okay. And so on. So there were some critiques of that came out of that. Then there were also some, Humsa Venkat and Melanie Graven then also talked about the fact that because of these inconsistencies, we ended up with teachers teaching in 4 different ways. There were 4 different pedagogic agendas happening in PowerPoint. Some people were teaching it like a maths lesson, some people were teaching it like some maths, some context, some people were doing these really immersive projects and real life applications. So there were different, so how do you assess that? If people are teaching it in 4 different ways, how do you create a national assessment that caters for all of that? Well, you can't. And so there's been challenges in the system. Okay. And then obviously, if you look at that just looks like it could come out of a maths textbook too. So, okay, so there's even in terms of how it was implemented in terms of textbooks, there were some challenges around that. Okay. And that's just from an examination question. If you look at the mark scheme, well, it's just really mathematics, isn't it? This is not how we function in the real world. So, and the key thing here is that the heavily mathematized methods, but also that successful practice in the subject is legitimized through the level of mathematical competence that you have. Okay? It's not about your real world problem solving, it's about mathematical competence. Okay. And so, and then myself and Evan Christensen, we critique the exams for exactly that reason. So that's really what that slide is about. Okay. And just so if I bring back Bernstein stuff into this, really what's happening is the recognition and realization rules rest in the ability to recognize mathematical elements and work accurately mathematical with those elements. And because the evaluation rules rest in the mathematics domain, that's what makes it possible for mathematical literacy to be compared to mathematics and positioned as a subset of mathematics. So we're foregrounding the mathematics, well, then the mathematics is at a lower level. Of course it is, because that was never the intention of the subject. Okay, so that's really where the critique comes from. It's because the evaluation rules are in the wrong place, perhaps. I want to think about it like that. Okay, I'm just going to skip through some of these. Okay. So let's just then think about what happened for the CAPS. So the CAPS came about, and I was very fortunate to be given the opportunity to be involved in this. These were the questions really that informed the development of the CAPS. So I was determined to try and push mathematical literacy through the CAPS further away from mathematics. I was trying to separate them out as separate subjects, like history and geography are separate. Everybody accepts that. I was trying to separate mathematics and mathematical literacy, even though they draw on the domain of mathematics and the domain and teacher education around mathematics. I was trying to separate them further apart. Okay. And those were the kind of the three questions that I was trying to answer. How can we shift the realization or recognition so that they're not based in the domain of mathematics? They need to be in something else. Okay. And so I'm going to walk you through this. So if we just think about this is the logic that's informed the CAPS. So if we think about mathematically literate behavior, is about being able to make empowered and critical real-life decisions. And how do you do that? Well, you do that by making sense of problems. And those problems need to be in both familiar and unfamiliar real-life context. And by real life, I don't mean made-up context, I mean real life. And how do you do that? Well, you do it by doing problem solving and by modeling. And how do you problem solve and modeling? Well, you use contextual knowledge and tools. So you use your understanding of the context. You can't make sense of a loan if you don't understand what a loan is. So there's contextual knowledge that's important, which you don't have the same problem with in mathematics in the same way. But alongside contextual knowledge, you also need mathematical knowledge. You also need some technological knowledge. And you also then need reasoning, critically communicating, and thinking contextually. And when you think about it like that, this is really complex. Okay, it's not simple. It's not just second rate, this is the long lost cousin, mathematical literacy sits over there to mathematics. This is a really complex idea that we're trying to get to support students through. Okay. So this came from some Sabenkat's work. She talks about life preparedness orientation. This really is embedded in the CAPS in a very detailed way. But basically, and this is positioned within the wider field of education internationally about situated modeling and critical mathematics. So, and I'll let you read that. I hate it when people put quotes up and read them, so then the assumption is you can't read them yourself. So the focus is on, thank you, the focus is on preparation for life. The focus isn't on how much mathematical knowledge you have. The end goal is something completely different. Now, how we measure that is complex, of course, but I'm just kind of talking about this at an intended level. Okay. And I'm going to skip through. So we'll read this one. A life preparedness orientation seeks to understand how people think, act, behave, and communicate in the world, and then to explore how they might think, act, behave, and communicate differently from a mathematically oriented perspective. And I think that's a worthy goal. We want to understand what people already do. Then we want to think, well, if we use mathematics, could we do it differently? Could we be more efficient? And what we might find out is, no, we can't. Okay? So you get a builder, he walks in the room, he looks in the room and he says, this is about 15 meters by 10 meters. Probably need about this many square meters of carpet. I'd be there with my ruler, measuring and trying to work out the surface area and then doing a division calculation. Okay, so both of them equally valid measures, but the question is, and you can improve on one using the other, the question is, do we always need to use the accurate measure, or do people in the world use alternative ways of thinking? Okay, and I'm just going to skip over that. But this, if we shift it, then the realization and recognition rules of mathematical literacy rest in a different place, because they rest in the ability to draw on a range of tools, one of which is mathematics, in order to critically analyze and solve problems and make informed decisions. The CAPS is trying to shift the realization and recognition rules in a different way. Okay. And you might want to then think about that as being the attained curriculum. That's what we want for our students, to leave school being able to do that. I'm going to skip over, oh no, I'm not going to skip over this, but these are the key elements of mathematical literacy in the CAPS document. Sorry, it's just jumping ahead. And I hope that those of you who are familiar with the CAPS document will recognize all of those elements. And then what I also then just want to jump on to show you is that if you look at the difference between that on the left-hand side and this on the right-hand side, I'm hoping that you would see more of those elements on the left-hand side than you will on the right-hand side. So the CAPS document is asking for that. It's not asking for this. Okay. That's an example, I think, of what the CAPS document is asking for. That's operationalized at a textbook level. Okay. That's another example about a Stokvel. And then there's some questions about sort of should you invest, shouldn't you invest? How can you model what will happen if you're the first person in versus the last person in, etc. The maths is really simple here. Maths isn't hard, but making sense of that's really complex. Okay, all right, even for educated adults. Okay, so just think about the realization and recognition rules are in a different place here. They're not about the mathematics here. The maths is a means to an end. There's something different happening here, if that's what you make the focus in mathematical literacy. Okay, so there were some curriculum design principles that tried to foreground this new agenda, this idea of life preparation. So first of all, we focused on application topics. And the idea was that the basic skills topics wouldn't really be assessed in the exams. It was the application topics that were the focus. So notice the word application. It's about using your knowledge. It wasn't about the maths you already understand. Then this wasn't done well enough, and I acknowledge that. But we did try and reframe the curriculum around what I would call phenomenological, can't even say the word, phenomenological categories, which are like broad themes rather than algebra, geometry. So we're trying to, and of course I didn't do that well enough. So probability, we could call chance, for example. And there is still something, and there are still topic sections that are just not, that are still too close to the mathematics equivalents. Okay. And then in terms of the curriculum structure, we specify, there's a deliberate specification of the context, of the scope of the context. So we're trying to make it, and there is like a, what is the word? I think it's here. No, just take a step back. That in grade 10, it was about context, thank you, that were more familiar. In grade 11, it was meant to be contexts that were less familiar. In grade 12, contexts that were unfamiliar. And obviously then as you move to unfamiliar context, the data becomes harder, etc. Okay, so that's the progression. But there was also this, and I think this was really important. So it's about using the following in the context of, in order to. Those statements were deliberate, because what they were trying to say was, whatever you use is a means to an end. The end is solving the problem. Okay, so that's what I was trying to do. So there's foregrounding of problem solving. And I've just got 1 minute left, so I'm going to jump ahead a little bit. Because what I want to do is that actually, at the moment, even though that was the intention, and you can kind of see on some of those smaller slides, there is a disconnect happening between what was intended in CAPS and what's actually happening. So there's nothing wrong with there are things wrong with the curriculum, but the curriculum intention is positive. What's happening on the ground is it's not that it's not positive, it's just teachers and assessors are doing something different, because do you know how hard it is to teach about Stokvels and inflation? It's really, really hard. The knowledge that you need is really detailed. And I don't think we've given due consideration to that you need a different type of knowledge to teach about the real world. You don't just need the mathematical knowledge, you need something much bigger than that. And language is the big issue. Words, language, communication. So there's all these sorts of issues that have come out, I think, which we didn't quite preempt. So there's a disconnect. And as a result of that, what's really happening is that that mathematical literacy is still focusing on a basic level of mathematical competence. And what that means is that it continues to be criticized as a lower level of qualification. Okay. I just want to end on a sort of an encouragement, because I know that there's some challenges, and this is the last thing I'm going to say. And I do have loads of slides that you can look at, but and so I'm going to just jump ahead to some of them, because we are currently in England having conversations about maths to 80 only now. So basically, students don't have to do maths once they finish their GCSEs at age 16. We are way ahead of the game on this. So even though there's significant teething issues, and there's significant structural issues and implementation issues. We're way ahead of the game, right? They're talking now about maths test piloted to help students prepare for real life situations. You can see the date. When was that? That was 2024. Okay, mathematical literacy came in 2003. So far ahead of the game on this. So, and this is a real encouragement. They're now just talking about curriculum review in England. Financial literacy is going to become a part of the new curriculum. Okay, right. So this is a real encouragement. I want you to be, like pleased about this. That yes, there's some challenges, but wow, we are way ahead of the game. What is this? This is the Royal Society produced something about a new approach to mathematical and data education, and they talk about maths literacy and data literacy. Again, this is all just mathematical literacy in a different guise. It's no different, and that's what they talk about. They talk about you're going to have foundational, advanced maths, domain-specific competencies, and general quantitative literacy. Well, mathematical literacy is the general quantitative literacy, so it's no different. This is in Ireland. They've now got numeracy across the curriculum. They've got a numeracy framework that's talking about all the same subject that we've talked about. Some of Sarah Bunslow's students, and Sarah's done some work around the pedagogical content knowledge needed for teaching contextual problems. They're only grappling with that now, like this year in Ireland. And in Australia, they've got the same thing. They've introduced numeracy across the curriculum. All the same stuff. So we are way, way ahead of the game. And that really is an encouragement to you, just to be able to say, despite all the challenges, despite frustrations, we're doing fantastic work. And we've actually been trailblazing. Still the only country in the world where we have a separate subject that's focused on supporting students for preparation for later life. Thank you very much.
Perfect. Thank you very, very much, Professor North. And as I said, I'm happy to take one or two questions of clarification, not as a discussion point, because we will have that later. Anyone who needs to have something clarified? No? Perfect. Then thank you very, very much. And again, I think this was a great. Oh, sorry. There's one. Sorry, Mark. One question of clarification, right?
And you can ask. Oh, I just wanted to find out about the name. You said something about the other thing, the passing of the hand. Yes. And then you said that is not connected. But you see, there is a lot in the name. Yes. So I just wanted to find out, because we have to involved in that. Yes. What was the reason? Was there no any other name that is meant for people to even, so that there is no. That's a good question. I'll bet 10 more chose with that. No, she doesn't. It's a very, and I think it's been a constant criticism the whole way through that by framing it at that, it sounds like you want them to be literate in mathematics, and that it makes it sound like you want them to be literate in mathematics, the students, and therefore that is a form of learning of mathematics. So, and it is a valid point, and certainly something that we can take forward. Thank you.
So thank you very much. As I said, this is not the time for discussion. That was for clarification. But thank you very much for the question. So again, thanks very much, Professor North. I now would like to ask our second keynote speaker for today. This is Dr. Stephen Taylor. He is the Director for Research Coordination, Monitoring and Evaluation at the South African Department of Basic Education. Similar to me, and relate to this quite well. He will actually present to us math and math literacy choices, what the data says or don't say. Please welcome with me Dr. Taylor.
Good morning, everyone. Right. While they find the presentation, a bit difficult because that was really thought-provoking and a lot to digest. I'm a bit thrown because I'm worried that there's going to be a lot of simplification going on now of complex issues. I feel a bit like when you're trying to work or go for exercise just after eating a big meal. There's a lot to digest, and I've got to suddenly present while I'm still trying to think about all the implications of what we've just heard. Great, looks like we've got it. All right, so mine is going to be a very different type of presentation. It's going to be much more just looking at trends in the data of what's been happening in terms of participation rates, subject choices, outcomes in maths and maths literacy over the years. So obviously we know, everyone here knows that this issue of maths versus maths literacy is a very topical issue. Currently, there's lots of debate. We saw the newspaper examples. It's quite political as well. We get lots of parliamentary questions to answer in the EBE about the numbers of schools not offering maths or children not taking maths. It's also historically, obviously, a very emotive issue, which I think we're also all well aware of. You know, behind the historical context to this analysis is quotes like the famous one from Verwoerd about what's the use of teaching an African child mathematics if there's no use for it later in life. So we know about this context, and that makes it quite a sensitive topic to debate and discuss as well. So I want to just look at some of the trends, and then talk about how can we improve subject selection and also outcomes in both maths and maths literacy. And I think there's some opportunities that the data allows, especially through linking various data sets as well. So not only looking at NSC trends, but also linking things like school-based assessments, data from earlier on to children's NSC outcomes later on, to start to understand the choices and outcomes that we see in the system. So that's what I'm going to hopefully do a little bit of today. So this shows the numbers taking mathematics since 2008, which I think was the first year that we had the NSC and we had maths and maths literacy. And I think the concern that a lot of people have is that the numbers taking mathematics has kind of stayed the same. It's fluctuated a little bit, but it hasn't really moved clearly in a direction over the years. At the same time, the overall numbers participating in NSC exams has increased. So that's part of the context, actually a declining share of participants are taking maths. So that's a concern that a lot of people have. But what happens if we decompose the numbers who took maths in matric into those who passed maths and those who failed maths? And so if we decompose that number, you see the green sections are those who passed mathematics and the red sections are those who failed. In other words, got less than 30%. And what's immediately obvious is that there's a lot of red. All right, so the maths pass rate is not very good. And just as a first observation, I think that's important context for discussing and debating whether more people should be taking mathematics. The existing pass rate is an important part of the context. And I would say already that, just based on this, that we need to just be clear in our thinking that we don't really want more maths participation as an end in itself. What we want is more maths passes. We want the green sections to go up. That's what matters. The number who take maths is irrelevant if new people who take maths fail maths. That's actually not helping anyone at all. So just to be clear, maths participation is only a means to an end, and the end is passing maths. All right. If we then add to this those who took maths literacy, maybe just before I do that, in the slides, this slide and the ones that follow, the green sections, I'm going to be characterizing these children as they took maths wisely because it turned out that they passed maths. So in hindsight, it was a wise choice. And those who failed maths, we can characterize as having been overly ambitious in hindsight again, because it maybe they would have been better off doing maths literacy. Now, I know that throughout this presentation now, having just heard what we heard, that's a bit of a simplification because we know it's not quite as simple as a kind of an easier version of maths. So I've very much taken that on board. But at the same time, I think there's still a choice to be made, and it's not just a choice of preference between which type of subject you'd like to do. There is also, I think, a degree in which children, especially who take mathematics, you want them to be equipped to take mathematics. I think there's still a consideration there. All right. If we then add to these numbers the number who took maths literacy overly cautiously, in the sense that they could potentially have taken mathematics. And again, that is a simplification because maybe there's, math literacy has, as we've just heard, a lot, maybe it has its own type of value, but at the same time, we do have national development goals around more maths passes and more high-level maths passes. So that is still an important outcome. So if we characterize them as overly cautious, those are the numbers that you add. So not a lot. And overly cautious here is defined as they took math literacy and they scored more than 65%. So, and based on some analysis of the data, we came up with that estimate of basically those who score 65% or above would have been predicted to have passed mathematics at the 30% level. All right, so it's getting a little fatter actually in the last couple of years, but it's usually not as many children as those who are being overly ambitious. So overly cautious selection of math literacy is not as common as overly ambitious selection of mathematics. If we then add the remaining NSC candidates there, these are those who took math literacy wisely in the sense that they scored less than 65% for math literacy. So in other words, the blue groups of children, in hindsight, they would not have been predicted to have passed mathematics. So it wouldn't be good advice to be telling them to take mathematics. And obviously this is at the point of being in the FET phase. So another very important caveat, which the conclusions and recommendations towards the end of my presentation will make more properly is that ultimately we do want more children to be taking and passing mathematics, but the way to do that is through better learning foundations earlier on so that they're well equipped to take mathematics. But just telling children at the point of being in the FET phase without the foundations to take maths because we want more maths participation might be setting many children up for failure. Right, so this is just one way of looking at the maths outcomes in the data. If we look at this by province, just for some of the recent years only combined, we see that Western Cape is probably the outlier here, in that in Western Cape you have more overly cautious learners opting for maths literacy than overly ambitious learners taking maths. But in all the other provinces, the red is thicker than the pink. In other words, the issue of overly ambitious selection of maths is more common than overly cautious selection of maths literacy. And then if we look at it by districts, picking Eastern Cape as an example, you see that across the districts, there are some very different patterns. So the 6 districts on the right are all districts with very high maths participation and very high maths failure rates, and very low overly cautious opting for maths literacy. These districts, though, have very low maths participation rates and quite a bit of overly cautious selection of maths literacy. And the point here is that if you're in the Eastern Cape department, you need to give different advice to the different districts. And maybe what this also reveals is that the sort of advice or instructions to schools about subject choices might be strongly coordinated through the district level. So maybe in some districts, they have a focus on more maths participation, and in other districts, the focus might be on we need pass rates to go up, so maybe less maths participation because that's the subject tripping so many children up. But clearly, the kind of emphasis should be different depending on the current situation in a district and obviously ultimately in a school. So yeah, I think it's as you drill down to districts that you see different patterns and therefore maybe a different emphasis is needed in terms of whether we're trying to encourage more maths participation or maybe less maths participation in some ways. Right. School size, just as kind of a brief aside, that school size is a part of the story. So what this graph shows is the two lines are the red line is small schools and the blue line is larger schools. And what it shows is the percentage of all NSC, percentage taking maths and failing maths. So those overly ambitious ones. And what you can see is it's always higher in small schools. And so part of the situation in many small schools is schools only offer maths or maths literacy. And that creates a difficult choice and is disadvantageous for some children. Because the school doesn't have the ability to offer a maths class and a maths literacy class. And so you end up with either disadvantaging children who could have done maths but now don't have the option, or children who are really poorly equipped to take maths, having to take maths because maths literacy is not offered at a school. That's probably a difficult one to solve, just based on post-provisioning norms and things like that. But it is part of the story that school size is part of the context. And then this is the point that Mark made as well, but I think it's worth emphasizing because in this debate, there's always the sense that like people are saying maths is more opens up more doors and more opportunities than maths literacy. So maths literacy gets critiqued as a subject that closes down opportunities and we want more children doing maths. But as Mark pointed out, the historical counterfactual was actually no maths. And as a result of the change in 2008, if you look at the numbers of matriculants passing some sort of mathematics, whether maths or maths literacy, and prior to 2008, whether maths high grade or maths standard grade, you see a big increase that has continued over the years. So the situation in recent years is that way more candidates leave the school system with some kind of a mathematics pass than in the past. And I think that's often lost in the media debates. If you read many articles, sort of implicit is a myth that somewhere in the past, things were much better, right? And we had now we introduced this maths literacy easy option, but in the past, maybe everyone did maths. But it's often sort of not quite explicitly stated, but there's the sense that things have deteriorated, everything's been dumbed down. And actually the situation I think is clearly better in terms of what we're producing every year. So that's again on somewhat of a positive note. Then just another interesting stat, which has been a topic of some debate in the media and parliament, is the number of schools that don't offer maths. Right, that's been a number floating around. When I checked in 2025, there were 463 schools not offering mathematics. And in total, I think it's about somewhere around 7,000 secondary schools or exam centers in the data. It varies across the years. The perception has often been that this is largely an issue in the Western Cape, but actually only 62 of those 463 were in the Western Cape. In the Eastern Cape had 87 schools that didn't offer maths. And I think that's largely because of the small school phenomenon, which is very common in the Eastern Cape. That you have a lot of small schools and they either offer maths or maths literacy, but they can't offer both. And then if we look at how that's changed over time, in 2016, there were only 320 schools not offering. Wait, let me just make sure I've written that correctly. Yeah, I think this should say maths. Sorry. This is in 2016 maths, so ignore the literacy. So the point here is that there are actually more schools now than a few years ago that don't offer maths. So that could be a point of concern, but again, I'm almost hesitant to judge it in case some of these schools are making a wise choice where they maybe are often small schools and they can't offer both, and they're realizing maybe they have an 80% failure rate or something, and therefore they're switching to offer maths literacy rather. And I think we should just be a little cautious in seeing this as a scandal, just because there are those kinds of realities that might be going on. If we then look at maths literacy, these numbers are from maths literacy. I remember it clearly because I did it this morning. So 432 schools in 2025 not offering maths literacy. So similar number actually that don't offer maths literacy. And in 2016 there were more such schools. So again, it could be that especially small schools are making that switch from maths to maths literacy when they have to choose one or the other. All right, so changing tack a little bit to focusing on high-level maths achievement and specifically amongst Black learners. And part of the point here, don't worry about the map here, I'll explain the map. But I think that one of the unhelpful narratives in the debate between maths and maths literacy is that the idea is that by taking maths literacy, you're preventing children from STEM courses in university. Now, I just think that it's different sides of this, it's different contexts. Like the children what's needed to get into STEM courses in university is more of high-level maths outcomes. And that's a different issue to whether you should take maths or maths literacy, because the children in that zone generally are taking maths. And the issue is we need to improve more children from levels of 40% or 50% to getting like 60% for maths. And that's a different kind of a policy issue than whether children who should take maths or maths literacy, because it's different children at making those choices. So by, for example, telling children who are not well equipped to pass maths at the 30% to take maths is not helping them get into a university course on maths. It's different parts of the system, different children, different solutions that are needed, but it gets muddied in the debate. As if just by pushing more children to math, suddenly they have access to a STEM career. But it is a really important outcome, especially if we focus on Black learners. And part of the reason for focusing in this analysis on Black learners is that the picture is different when you include or exclude, especially white and Indian learners. In terms of which provinces and which districts give the best educational opportunities. So what this map shows for South Africa and the island of Gauteng, out there in the sea, low enough so you can see the districts. It's a small province, so to get into space, you can see it a bit better. And this is work done by my colleague Martin Gustafsson. By the way, I just need to acknowledge that for this graph. So what the map shows is all the education districts color-coded by the percentage of Black learners who were 15 in 2018, who went on to reach matric, take maths, and score at least 60% for maths. So it's the baseline is all 15-year-olds in 2018. So it's sort of taking account for issues of throughput and because some provinces there's more dropout than others. So you want to kind of put it on an equal playing field and say, relative to the underlying population of Black learners, how many went on to reach matric and get a high-level maths pass? And what you can see is that actually the Western Cape and Northern Cape does not do very well. Black learners in those districts, generally it's less than 1% of them in some of those districts who end up getting a high-level maths pass. Limpopo and parts of Gauteng, but especially Limpopo, actually stand out as providing the best opportunity, where in some districts there more than 4% of all Black learners went on to achieve a high-level maths pass. And the picture is a bit different when you include all learners. So I think for historical reasons and for transformation of STEM careers and things like that, it's possibly worth looking at who's providing the best opportunities. I mean, maybe a slightly different analysis would have been to restrict to say quintile 1, 2, 3 schools. Would have been a different way of saying taking account of socioeconomic differences across provinces. who's providing the best opportunities to succeed and to get a high-level maths pass. So this is a slightly different issue from the question of maths versus maths literacy, but I think it's also maybe just worth talking about a little bit. And then this is the same analysis. So what we have on the vertical axis is the percentage of all Black learners who achieve the high-level maths pass at 60% or more, again against the official 2024 pass rate. So the traditional matric pass rate, and each dot is a district. And what's clear is that a district like this one, which now is not labeled, but I think it's one of the Chuanes, if I'm not mistaken, this one, in Gauteng, had the best pass rate in the country out of all the districts, but was kind of average in terms of the percentage of all Black candidates who went on to get a high-level maths pass. On the other hand, the district right up there, which I think is Capricorn. Yeah, I think it's Capricorn in Limpopo, is kind of average in terms of the pass rate. But it's the best district in terms of almost 6% of all Black learners got a high-level maths pass. So there's some interesting things happening in certain districts around maths, and especially high-level achievement. So just an interesting little bit of analysis there. Right, the next part of the presentation links matric data to earlier educational data to see what predicts success. And in particular, the data that I've linked is the annual national assessments data from 2012. I've linked to the children that wrote Anna, in this case, the grade 6 children. So it's a population of all children in the country. And I found them in NSC datasets years later. Obviously, some children I did not find at all. But what it shows in this case is the percentage who were found in NSC based on their maths achievement in grade 6 in the ANAs. And the 10 deciles of achievement is basically the 10th decile is the top 10% of children in grade 6. Decile 1 is the lowest performing 10% of children in grade 6. And what you can see is that for the lowest percentage of children, only 41% of them were found in matric data 6 years later. Most of the remainder would have dropped out, but I have to also acknowledge to some extent there's some mismatching going on. There's some limitations in the matching based on identifying information not being perfect. So it's probably not as large as 59% who dropped out, but most of that gap is dropout. Whereas for the strong maths achievers in grade 6, 83% of them were found in NSC data 6 years later. So there's clear predictive power of early achievement for later educational success. The next graph shows the exact same thing, except the outcome now is not reaching matric. It's your percentage score in NSC mathematics. And if I'm not mistaken, I've kind of combined maths and math literacy scores into one metric for this analysis. But again, what you see is that for the weakest 10% of children in grade 6, years later, on average, they got 32% for a combination of maths and math literacy. And for the strongest 10% of children, the average score was 64%. And obviously, there's a clear positive pattern. Right. So the point being made by this is that we obviously we want to improve maths outcomes, but it needs to start early on. It needs to be through equipping children early on so that they are equipped to do maths well. That's the strategy rather than just sort of trying to promote maths participation at the end. All right, then the next bit of analysis, this doesn't feels like it's misplaced. So let me start here. The next bit of analysis is linking SBA data, so school-based assessment data, to matric data. And the rationale for doing this is that because we've seen such high failure rates in parts of the system, especially in maths, the question I had was, what was informing that subject choice when it was made? Obviously, small schools is one constraining factor, but I immediately thought of school-based assessment scores. What were schools looking at when they suggested for some children to take maths and others to take maths literacy? And you know, one possibility I thought was that maybe the grade 9 or grade 10 school-based assessment scores were very lenient. And maybe schools were under this, like, and schools and learners and parents were under a sort of an illusion that things were going fine, and therefore they took maths. But I wanted to see, is that the case? And there were a few surprises. But just a few overall points about school-based assessment data that some of the analysis is showing. The first thing is that within schools, school-based assessments are actually providing quite an accurate ranking of learners. So that's a good thing, because in many ways, the main users of school-based assessments are schools themselves, and you need to know which are your strongest and which are your weaker learners in each subject. So within schools, they actually do provide quite a meaningful ranking of learners. But between schools, the school average SBA marks do not provide a very accurate ranking of schools. And I'll show you that with some data in a moment. But it creates a problem then for us as national or provincial or district officials wishing to identify which schools are strong, which schools are in need of extra support. If SBA scores are not really distinguishing between schools in a meaningful way, that's a potential problem. Math scores, in particular, are high in the foundation phase, are somewhere in between in the intermediate phase, and are low in the senior phase. So this, and I'll show you that with the graph as well, but it creates, I think, a misleading picture of things are right early on, but the problems are later on. I actually think that's a dangerous narrative, because I think TIMS gives us a bit of a reality check on that, because in TIMS we've participated at the grade 5 level and at the grade 9 level. And actually we have a slightly larger percentage of children reaching the low international benchmark in grade 9 than in grade 5. So I think that sort of more externally standardized assessments do not tell a story of things are looking good early on, but bad later on. I think the challenges actually start earlier on. So we must be careful of that narrative emerging from what SBA scores tell us. So to show this in the data, so these are density curves, so it's like the overall distribution of scores. So if we look at the blue, this is grade 3 SBA scores in term 4 of 2024. And you can see that most scores are quite high. The mode is somewhere above 60%, maybe actually 70%. So the bulk of SBA scores in grade 3 are looking pretty good, like 60 to 80, even like large numbers getting up to 90% in maths in grade 3. For grade 6, the pink one, I've only just selected certain grades because it would be too busy if I put every grade there. But for grade 6, you can see somewhere in between. The mode scores are about just below 60%. But grade 8 and 9, you see the mode scores are very low, like 30%. So that's the misleading picture I was talking about, where if you just look at this graph, you might think things are great early on and terrible later on. I mean, the other interesting little pattern in this graph that you might have noticed is that you can tell that the pass mark must be 40%. Because you have, if you take grade 8 to 9 as a special case, but they all have this, you have hardly anyone scoring 38, 39. And loads of people scoring 40 and 41. Thanks. So that's just, and I think this already points to a dilemma around SBA marks. The dilemma is that schools can't have huge rates of repetition. You just can't have half of a grade repeating. So you have to, the SBA scores have to kind of respond to that and react to what the pass criteria is. Rather than the pass criteria and the pass outcomes reacting to what the learning is. All right, so that's just an interesting pattern that you see in the data. Okay, this one shows the why I think we lack an externally standardized measure. So with this graph uses, so each dot is a school, there's 710 dots. And this is from the Funda Uphumelele reading survey. So it's not maths at all, but the point is just a useful data point to use because Funda Uphumelele was an externally administered standardized assessment of early grade reading that was done last year. And it was measured the percentage of learners reaching key reading benchmarks, in this case by the end of grade 3. So for each school, each dot is a school, you can see the percentage of learners who reached a benchmark, and you can see it ranges wildly. You've got some schools here where no learners reached the benchmark by the end of grade 3, and some where the majority of learners did meet reading benchmarks. But the x-axis is the school's average SBA score at the end of grade 3. It's the same cohort of children. And you can see that almost everyone's in the 60 to 80% zone. So this creates the problem because in reality, you've got some schools that are really weakly performing and others that are quite strong. But if you're looking at SBA scores as a system, they all look somewhere in between 60 and 80%. So they really don't tell you which schools are in need of support and which schools are doing quite well. All right. And then there's a similar problem at NSC. So that was an example from foundation phase. I did a little exercise to say that if a district was using grade 11 term 1 SBAs to predict which 25% of schools would have the highest rate of NSC candidates failing matric in the following year. What I discovered is that you'd only successfully identify about 50% of the actual schools that would do that. And you get some very wrong if you use SBA scores. And you would do better to just use the previous year's NSC results to predict which schools are going to have the highest risk of failure the next year. So it's just another example of where SBAs are not really providing that accurate signal at a school level to inform things like support. All right. Few slides might have stopped. Order of a few things went a bit funny here. Okay, let me start with this one. So another bit of analysis looked at 2017 SBA scores and compared them to 2019 matric outcomes. And what I found is that in quintile 1, 2, and 3 schools, across most provinces, including this analysis, the correlation between the school's performance in the school's maths SBA scores in grade 10 and the school's matric maths outcomes is basically 0. In fact, it's slightly negative. But basically, and slightly negative means that schools that did a little bit worse in their SBA scores actually were the schools that did a little bit better in matric. So, but in quintile 5 schools, you see a much more positive, as you would expect, correlation between what a school's SBA scores are saying and their maths matric scores 2 years later. So again, it's the reliability at a school level issue. And this was the same thing by province. So in Gauteng and Northern Cape, in this case, we had quite good correlations between SBA scores and matric outcomes 2 years later. In other provinces, the correlations were much lower. And so I focused in then on schools with more than 50% failure rates in maths, because I wanted to see what were they looking at in terms of their SBA scores 2 years earlier. And so this is only schools with more than 50% failure in maths. And the graph on the left shows is the percentage of NSC candidates taking maths in 2019. And you see that there's quite a lot of schools where everyone takes maths. So this is again a situation of they only offer maths, and that's partly why they have such high failure rates. The graph on the right shows the school's average grade 10 maths SBA scores in 2017. And what surprised me was the scores were very, very low. I thought my hypothesis, as I mentioned earlier, was that maybe they were looking at a positive illusion, like overly lenient SBA scores. But actually, schools were looking at very low. Mode is around 20%. Schools were looking at very poor maths outcomes and still offering maths to a large extent. So that was a surprise. This shows another strange pattern where you have the school's grade 10 maths composite measure, so combining maths and maths literacy, and the predicted percentage who took maths 2 years later. And it's, if we look at, say, quintile 5 and independent schools, you see what you would expect. You see that in schools with very low grade 10 maths performance in 2017, you see lower participation rates in matric maths 2 years later. And then as the school gets better in terms of its SBA scores, you see high participation rates in maths. But in quintile 1, and also to some extent quintile 2 to 4, but especially quintile 1, the quintile 1 schools with the worst maths performance are the most likely to offer maths in matric. Yeah. It's a strange pattern that you see. And it's partly a question to the floor as to what is driving that. Is there sort of a prestige of saying we have high maths participation, or we only offer maths at this school, and yet they end up with extremely high failure rates? And then by province, you see that there's a clustering of provinces that in Gauteng, Northwest, and Northern Cape, you saw this pattern of as your SBA scores improved, you saw more participation in maths. But in Eastern Cape, KZN, Limpopo, and Mpumalanga, kind of like quintile 1, 2, and 3 schools, you see very high participation amongst your worst performing schools. All right, I have a proposal that I'm keen to try. Is to provide targeted guidance to different types of schools based on their maths participation and outcomes. So the idea here was that when I spoke to Mr. Tlabane, I think it was after the 2023 exams, where we saw improvements. There was some improvement in the maths pass rate. Yeah, he suggested to me that one of the reasons for the improvements in the maths pass rate that year was that there'd been kind of guidance through the districts and provinces to target the sort of lower order parts of the paper to sort of help children get that 30% right. And I thought, well, that's actually very good advice, but for some schools, and maybe other schools need different advice. So sort of building on the Tlabane doctrine, I thought, what if we take that logic and extend it a little bit and identify 5 different categories of schools. And so the first category was schools where you have more than 40% of learners achieving less than 20% in maths. So very high failure rates and bad failures, like not even close to 30. And the idea would be that for those schools, the right sort of advice would be perhaps you should have more children taking maths literacy. Again, I'm a little nervous about this kind of logic being sort of contributing to the stigma around maths literacy, but with that caveat in mind, category 2 was where you have more than 35% of learners. So again, a lot of learners scoring between 20% and 35% in maths. And that was the group where I thought that the Tlabane doctrine would be appropriate, because that's a group where you've got lots of children maybe just failing maths or around about the failure mark, and we could significantly improve the percentage of learners who pass in those schools. Another category of schools where you had more than 30% of learners scoring between 35% and 60%. And there again, they might need slightly different pedagogical advice to get more high-level achievers. Then category 4 was where you have more than 40% of learners achieving more than 60% in maths, and for them, it's sort of keep doing what you're doing because they have very good results. Category 5 is where you have more than 20% of learners achieving more than 65% for maths literacy, and those schools might be your sort of overly cautious schools, where those schools could be targeted for more maths participation. All right, so the idea is like, let's tailor the advice depending on the context. And this shows the percentage of schools in each category. Most are in category 3 actually, which is they can move from low performance in maths to high performance. But quite a lot in category 1, which is maybe there's a lot of overambitious math subject selection. And then we could have some sort of report card explaining the existing performance and subject selections and making some pedagogical suggestions. So then, to conclude, just one little thing that I hoped to get done by today, but I didn't manage to fully do it, but it's on my to-do list, is to simulate how many candidates would have passed matric overall had they opted for math literacy instead of maths. And I know that there's a critique that this is sort of chasing pass rates, but I think from the individual's perspective, it's right to chase a pass rate. For a child, you should want to pass matric. So you want to make subject choices that give you the best shot. So I don't think it should just be dismissed as chasing pass rates. Then I do think we need tailored interventions for the FET phase around guiding better subject choices. And then part of this is about better subject selections, but part of this is also about helping those parts of the system where they are sort of most ready to produce more high-level maths outcomes. And actually, I did analysis, not in this presentation, but I looked at sort of like, can we identify schools that are especially large schools where you have a lot of children, especially Black African children, who are in that sort of 40–50% zone, that if you did educational interventions in those schools, you might significantly increase the number of high-level maths passes. And I think there could be something done in just 200 or 300 schools in the country that would actually help us significantly address that part of the need. We do probably need to think about our school-based assessment data, but I also want to caution against just fixing SBAs in some way, because there is a real dilemma, I think, that schools face, where they can't have 50% repetition rates. So they can't be having sort of brutally honest SBA scores that then leads to failure rates. So there's something we need to do there, but it might not be a simplistic solution. But hopefully, as we sort of improve the signal there, we also encourage better use of school-based assessment data, especially in schools, so that it contributes to more efficient subject selection. Because I think a lot of this is about the right subject selection. It's not just about telling more people to do maths or more to do maths literacy. It's about the right children making the right choices, like guiding that choice. But the biggest thing, obviously, we need to do is to improve learning foundations, because that's how we improve the percentage of children who really are equipped to take mathematics in the FET phase and actually will be equipped to do well in math literacy. Because as I think the previous presentation really showed us, there's a lot of value in math literacy as well in itself, not just as a backup plan to mathematics. And so all of those outcomes would be improved by better learning foundations. And also, I think one other thing that stood out from Mark's presentation was just thinking about the dependency on language and literacy and math literacy. You could make a similar argument that foundational literacy is also important for improving maths and especially math literacy outcomes later on. So proving things early on is what we really need to do most of the work around, and then more efficient subject selection towards the end. Thanks for listening.
Thank you very, very much, Dr. Taylor. As I mentioned at the beginning, we are taking a short, and seriously a short body break, comfort break. So let's do this for 5 minutes. We really would like to go into the discussion. So please, if you take a break, please be back in 5 minutes time. Thank you very much. Yeah. Okay, sorry, I was asked to say the actual time, so please be back at 55. Please be back at 55.
I knew they were keeping time. I saw him. They were not time. That's there's nothing smart in it. There's keeping time. Yeah. So I mean, that's all my thought. Good job. Good job. The first one. But it was well. Very well. This table is long. This table is long. Bobby. This table is long.
Check sound. Sound check. Sound check.
They're not loud. They're not loud.
One more.
They're not loud enough.
Loud enough. This one is loud. This one is loud. This one is loud enough. Oh. Only you need here to the front. Okay, you got that one.
Which ones are for the flow? And keep it.
Sorry, we're going to have a tea break. So that's the short break. So can I just ask everyone to come back in, please? So just last week,
Thank you very much. Can we please take seats again? No, I know. Okay, perfect. Thank you very much. So what we do, sorry, excuse me. Okay, so what we will do is we will have both keynote speakers at the front, right? And I'll see already one hand. Thank you very much. So what we will do is we will take 3 or 4 questions, right? Take 3 or 4 questions. We will then ask the keynote speakers to respond to that, right? And then sort of hopefully with that sort of start our engagement as well. Perfect. Thank you very much. Also understand that, again, after both presentations, people wanted to have a slightly longer break. We will have the tea break, the proper tea break after the discussion at half past. Perfect. So let's get started. I had one hand. Oh, but that's a very nice one. So I will take two from this side and two from this side. I had the one lady in the back, and then I'll just take this gentleman. Right? That's two from this side. You can take your hand down for the time being, right? And then here, did you have a hand up? No? Okay. From this side, I've got 1, 2 questions from this side then as well. Okay. Can I please ask for the question? It's not working. Sorry. Can we have a different microphone? Sorry, can I please ask you, would you please introduce yourself very briefly and just also ask which keynote speaker you are addressing?
Thank you very much. Marina Westlock from the SAOU. I'm not going to address Professor North at the moment. I will allow him to just watch the wildlife outside and enjoy the sunshine. Hopefully he'll take a couple of photos to take with as well. So Dr. Taylor, I'm so sorry, but most of my comments and my questions will be directed at you. That is just because we work more closely with the data and we have a good overview of what we do. The first thing that I want to say is that I am slightly upset that we only have the 2 mathematics options here this morning. We know that in South Africa, we have mathematical literacy, mathematics, but we also have technical math. Now, when the unions, and we are stakeholders in processes, started with the curriculum revision, we hoped that technical mathematics would come in as a middle ground to allow for certain of the deficits that both of you have highlighted today. So I hope that at the next engagement, we will also start looking at technical mathematics, at addressing the issues with mathematics specifically so that we can accommodate more learners in this field. The second thing that I want to say, and this unfortunately is in your 2025 NSC report, so it's not something that I got from some obscure venue, but the number of candidates at 60% for both mathematics and mathematical literacy is really concerning. And what we are very, very worried about from the union side at this stage is the number of distinctions in mathematics. For this year, we have 3,600 distinctions in mathematics, which is not a good place to be. We try to figure out whether the SPAs are negatively affected through the Umalusi standardization processes and whether this is actually negatively impacting on the number of distinctions for mathematics. But that correlate we still have to figure out a little bit. But I do want to mention, and this is my last polite comment before I come to the less polite comments, is that learners who move from mathematics to mathematical literacy is sometimes a very bad move because these learners assume, and there are various mentions to maths light and maths score and whatever else, is that if you move to mathematical literacy from mathematics, you are going to fare a lot better than those candidates, and we do not see that in the results. So maybe there should be some kind of information for learners moving from one to the other, that you are not necessarily going to now suddenly achieve distinctions because you move to mathematical literacy. And then, Dr. Taylor, I am very sad and sorry to say that the silos within the Department of Basic Education still exist. We have management by circular. Circulars come out every year, and they regulate the progression through the system and combination. The combination for mathematics is done from grade 4, basically up to grade 11. That means that a candidate in grade 9 never knows how well they fared in mathematics because they are just being condoned. So therefore, they have this overinflated idea that they are going to do well in mathematics. The ranking system that we have for the NSC puts a lot of pressure on the provinces so that they cannot do gatekeeping for learners moving from grade 9 to grade 10 and offering mathematics. Those two things, combination, progression, gatekeeping, is resulting in the results that you have seen with regard to mathematics at the moment. Thank you very much for both your presentations and good luck for the discussion.
Thank you very much. Thank you. And I think that's perfectly fine. But as we have lots and lots of attendance, and I really just sort of ask you to sort of make one comment or at max two, right? So that we can give a lot of people the chance. I had one more candidate here. No, actually, no, it wasn't. It was this gentleman. Sorry? Not by, that's fine. We will come back. We will come back. Sorry, yes, can I please ask you?
Thank you. Good morning once more, colleagues. My name is Franz Fawe. I'm from the South African Council for Educators. Mine is quite, I think they might be targeted to Dr. Taylor. You did make a very good presentation, but however, I think some of the missing things that we perhaps could discuss today is how can we better repackage CSI spending on continuous professional development on teachers, because as much as we're more interested on the uptake of pure maths than mathematical literacy, at the end of the day, we would still have a high number of learners who are still failing mathematics at grade 12 and cannot enter university or even go to TVET colleges, and they end up going to that category of the need group. And secondly, your comparison, especially on the data you provided between the Western Cape and Limpopo and other provinces. Now we're shifting to the language of teaching and learning. When you look at in Limpopo, they teach mostly in English, and in Western Cape, they are highly more favored in terms of language, but we are still struggling. How can we bridge that particular gap there? Thank you.
Perfect. Thank you very much. And then I said I'll take two questions here. I have one here and one in the back.
Thank you so much. Just on a lighter note, Dr. Taylor, thank you for letting us know that we live in a more mathematically literate country. And I think between that and 0.5% decline in unemployment, we've got a full-on election campaign. I just want to, my name is Khotso, so I'm with Omucho. I want to just ask a question. I think it's directed to Progno. In your earlier thinking, and maybe take that thinking to the current situation, what was your assumption about teacher preparation, teacher training, or skill set? What did you assume for maths lit specifically?
Thank you very much. And then the last one, the gentleman in the back. But it's coming. But thank you.
Thank you. It's Banda from Northwest University. My question is directed to Dr. Taylor again, because the presentation was more on maths, and then I would have been interested in terms of the combination, because it could have been a predictor in terms of where these learners end. To say, perhaps, if these learners are taking mathematics with physics or mathematics with economics, because it already becomes a predictor in terms of the career pathing those students are most likely to take. And at that point, it becomes easier for us now to see where they end up, whether they might end up in the streets or in TVET colleges or in universities, and how was that mathematics going to help them in their career. So I would have wished to see that kind of combination, and then it was going to give us a clearer picture and to paint a better picture in terms of the importance of mathematics as a subject. But on its own, the presentation, it sounds as if you just need to pass, and then where you are going to end up, you see. So for me, it becomes a little bit of a challenge there. Thanks.
Perfect. Thank you very much. I now would like to ask the keynote speakers, and seeing that Stephen had a lot, maybe we start with Mark.
Okay. Was it Khotso? Did I get that right? Okay. Khotso, you're asking about teacher training, mathematical literacy.
So the process was that after the caps had been published, we then met with we had a national training team, and we met with all the subject advisors from all the provinces and the CESs for mathematical literacy and mathematics, and we ran intensive training, and then those subject advisors, the CESs and subject advisors, then went out to their districts and did training. So and a lot of these messages would have been communicated through the training. I think the realities on the ground. So when I was talking earlier about the disconnect between sort of intended curriculum, implemented curriculum, assessed curriculum, I think, I mean, and this is not, because I don't hold, you know, I don't blame anybody for the disconnect that's happening. What's happened is that in the absence of the teachers, and you know, at an assessment level, at a textbook development level, etc. You know, when you try to, in the absence of having a deep contextual understanding of very complex ideas like financial indices, national inflation rates, all those kinds of, you know, gross domestic product of the, you know, at a national level, etc. What we tend to do is, because we're all really keen about the maths, and actually the maths is the safe space, we teach the maths because that's what we can teach. And I think that that's really what's happened, is that the teachers want, and then there's the significant reading burden and the comprehension issue around language. And so I think what the teachers have done, many teachers have done, is tried their very best in terms of, we want to make sure that the children learn, sort of have a positive learning experience. We can recognize the mathematical components of that. And so that's where we're going to put most of our attention into. And then, of course, in some other contexts, the teachers that are doing the most fantastic work around contextualization and problem solving, etc. So I don't think it was there was certainly from central government, there were some clear messages that went out into schools. I think it's just in the realities of teachers on the ground, having to put that into action is really complex. And I think, you know, there would have needed to be more direct and ongoing support for teachers in order to, you know, in order to assist. And of course, the same messages have gone out to publishers, but different textbook publishers have produced their, you know, textbooks that vary considerably in terms of the way in which some textbooks are very focused on real life applications, some are very mathematical. So that causes confusion in the system too. So it wasn't through lack of effort. I think it's an incredibly complex space, and it's much more complex to roll out that type of a qualification with a very short history, as opposed to something mathematical, which is much more clearly defined and ring-fenced. So.
Okay, thank you so much for all the questions. Firstly, Morena, you're actually quite polite. Yeah, I was waiting. I was getting more and more nervous. I was waiting for the proper attack. It felt like it never really came, but I think you raised important questions, which I tend to agree with as issues. So the question about technical maths. So initially, my sort of position on that in the analysis was that relatively small numbers of children are taking technical maths, so that it doesn't significantly change the overall picture or story. But I think the numbers that have been taking technical maths has been increasing each year in the last few years. But I think it is getting to the point now where I recognize I need to look into it a bit and see how many learners does this now account for. I mean, I think it's around 7,000 or so. So it's still quite small compared to the overall numbers, but to what, like, who is it? And like, we start to need to look into it a little bit more carefully in the data. So that point is well noted. I mean, I think as you saw, I do also care about the high level results. But I think it's a slightly separate part of the discussion from the question about who should take maths and who should take maths literacy. I think that the issue of how do we get more high level maths and even high level and even distinctions is an important one. One small caveat there is that I know that the results, especially at the high end, went down in this last year of maths. I am still waiting to look into that. I'm not convinced that it's sort of necessarily a very alarming trend. I know, and I'm relying partly here on work that Martin Gustafsson has done in the past, where he's tried to sort of adjust for possible differences in exam difficulties from one year to the next. I know that the Umalusi standardization process to some extent accounts for that. It's a good process, but it may not be perfect. And I know Martin has said recently that based on his previous analysis of how maths and physical science trends fluctuate a bit, he is, I think he said 95% sure that the latest declines are probably just slight differences in exam difficulty, which also can affect things differentially at the top end versus, say, the mid-range of scores. So I think we need to look into that more carefully. I doubt it's SBAs. I highly doubt it's the contribution of SBAs bringing the overall results down. But perhaps the colleagues at Umalusi can comment on that one as well. Then I also think you raised a good question about the movements between maths and maths literacy. So within the FET phase, obviously, because not everyone takes one subject in grade 10 and sticks with it to grade 12. There's some movement, and I think we do need to understand the extent of that movement and the dynamics within those movements, because I think the issues you raise are important ones. It may not be simple, and I think that point relates to the proposal to make both subjects possible to take, right? There's this idea that maybe why do we force the choice and force children to either take a safe route or perceived safe route in math literacy or go for maths? Like, why is there this choice? And I know I think IEB have been piloting an option where you can take both. I initially thought that sounded like a very sensible idea, but I also have heard presentations from others in the DBE, especially in the exam section, which showed that there's quite a lot of context and considerations and practical difficulties with doing that. So I'm not, it doesn't seem like an obvious no-brainer that should be the solution either. So yeah, more work to be done there, and similarly more work to be done to understand the impact of the condemnation circulars over the last few years. Those points are well taken, all of them. And fortunately, I think in the end, there was nothing too impolite or anything that I want to fight about. France, thank you for your points. I think what you essentially are doing is you're taking the discussion to how do we improve fundamentally the learning and teaching of maths, which I think was my sort of conclusion, is that's what we need to do. But in some ways, it's a whole new discussion of like, okay, what does the evidence suggest around what works to improve maths learning and teaching? To what extent should those be professional support programs to teachers in service? To what extent do we need to do things differently in pre-service? To what extent can better materials help? And I think there are some things one could talk about there. We could hear all about the maths improvement program, which I think is building off the TMU framework. So I think there are quality driver improvements happening. We still need to build that evidence base a bit more around really understanding what works, the cost effectiveness options on the table for that. Similarly, around the use of language in mathematics, I know that the TMU framework does have pedagogical advice on the use of language to facilitate math learning. So I think it's those kinds of things. Even the rollout of MTBBE in the sector, it's really about understanding to what extent are those quality driver reforms going to shift things, because that is what you're looking at. Okay, how do we actually do this? And it's exactly those kinds of things we need to discuss. Court, so I don't think you had anything for me, but just good luck for the election campaign. All right, then Sibanda. Another important question you raised about the subject combinations that often goes along with maths participation. Again, something I didn't have time to get into, and something I should, it's on my sort of to-do list of like how to take the analysis further. To what extent maths and physical science go together as a package, and does that drive some of the choices? Those kinds of things we definitely need to look into more. And you're absolutely right that the story doesn't just end with your matric outcome. The question is, how does this open up these later on in university, in the labor market? I think we have some data limitations there, and maybe work that needs to be done in linking administrative data sets. So there's been a little bit of collaborations between DBE and DHET, for instance, to link matric data with TVET college databases, TVET-MIS, I think it is, and also with HEMIS, which is for universities. Much more of that kind of data linking needs to be done to understand the flows from school into college and from school into universities. There has been some done. One standout finding from the work linking DBE data to TVET data is that almost everyone who enters TVET colleges has already been through the NSE. And that's a sort of an articulation problem, but it's not as if those who do not complete NSE are generally the ones entering TVET colleges. Then on even not only the universities, but ultimately sort of labor market performance. I know of one initiative in process. I know that it's I think Status A, Treasury, and others have a program called Mzansi Exchange, which is basically about data sharing across government. And through that process, I know that the DBE has shared some NSE results with SARS, who are extremely protective, as you can imagine, of tax data. But there has been some linking done there. And I'm very eager to start to see what analysis comes out of that process, to start to understand the links between NSE, specific NSE outcomes and labor market outcomes. But there's a lot, it's work that's hard to do. But I think we know enough from the labor economics literature on returns to education that getting maths and maths as an entry point into certain university courses, it does have economic returns. I think we can be quite sure of that. Just as matric versus not having matric does lead to a different rate of employability and earnings, despite the sort of rhetoric of is matric still worth the papers written on. There is a difference in labor market outperformance for those with matric and those without, and similarly there is a difference between those with university qualifications and those without. And so I'm sure that there is an impact of taking maths and of getting high level maths outcomes, but we need to do more analysis to better understand the magnitude of those impacts. Thank you.
Great, thank you very much. I will take two questions from the room, and I will actually also, as we have online participants, also take questions there. I did promise that, yes, I already have one taker here, and can I maybe take someone? Okay, then I've got you, the gentleman here as well.
Thank
Sorry,
you so
and
much.
again, please, one question.
Yes, one question. I'm actually happy because the question I wanted to ask about the technical maths has been done. So that takes me down to one question. My name is Priscilla Ogunbanjo from the Department of Basic Education. Thank you so much, Prof. and Dr. Taylor, for the presentations that you made. I want to say that it's just a bit of a comment and a question. The comment is the fact that I think it's very clear we understand the rationale for maths literacy. Prof has also reminded us. We understand that maths literacy has a place, but I believe that our issue as a country is the fact that we are looking at the skills in STEM careers that we do not have as a country, or that we are lacking in. We're also looking at the fact that we're not meeting our NDP target in terms of that. So the question would be, how do we increase the number of people taking subjects, which of course, that's where mathematics comes in. That's the whole debate about maths. How do we increase the number of people taking maths, so that it will lead to improving those STEM skills and careers that we are looking at, encouraging that participation and success without necessarily forcing the people to take maths who should be taking maths literacy. At this point in time, we do have about a 2% taking technical maths. It's about 34% in mathematics, 2% technical maths, 64% in maths literacy. So the 20% is what we want to move over from maths literacy to mathematics, because we're looking at about a 50 to 60% participation and success in maths. So how do we foster that? Not necessarily maths only, but you're looking at 40% in maths literacy, but a 60% split between technical maths and mathematics. How do we get that 50 to 60% in that area that leads to the STEM skills that we're looking for as a country? going forward. And I want to say that some of the categories that Dr. Taylor gave, that category 4 and 5, I think begins to answer the question. So maybe DBE, yes, working in silos, guilty as charged, should come together and begin to look at how we can work out a framework for that kind of program going forward. Thank you.
Perfect. Thank you very much. And then I have the gentleman here.
Good morning. Dr. North, I just want to reiterate what the colleague has said, that mathematical literacy, the issue is in the name. So basically, I didn't have a question. Now, here's my question. I'll direct mine to Dr. Taylor and say, does the department have a plan to have a research-based guided choice in helping the students to take either mathematical literacy or mathematics, as that we need to look at the holistic view of the students and the individual wiring of the students. Then I also want to say,
because we're actually running out of time.
Okay.
And I still would like them to respond. And there's one question also still coming from Professor Moore. Thank you.
So just in response to yours, I mean, I know that the points taken about increasing STEM careers and about your question about how do we increase the number of people taking maths to improve sort of participation in STEM. I mean, why are the students failing maths? That's the issue. If they weren't failing maths, then mathematical literacy wouldn't be an option or a need. So there's an issue around, for me, you solve the problem by focusing on teacher development, teacher subject and pedagogical knowledge, and starting with in the primary school, and then obviously, strategically building up to the system. But yeah, I think that the distinction between maths and maths lit has become a bit of a scapegoat for an issue that's much harder to solve. It's really easy to criticize curriculum and criticize qualification structure. It's much harder to invest significant amounts of money into developing your human resource.
Yeah, I agree. I think the way you frame the question is, I think the way the question is often framed, but maybe could be slightly reframed. You said, how do we increase maths participation so that we open up more STEM career opportunities? And I think what I was trying to suggest is that they're slightly different questions. They're not just one trajectory, because maybe, I know I had 4 groups of learners, but if we talk about 3 different groups, maybe there's those whose maths foundations are unfortunately very weak and who should be taking math literacy. Then at the other extreme, there are those who are taking maths already, and the question is, how do we get them to high-level maths results? And so moving from 40-50%, which is already more than, like, there's loads of people passing maths at the 30-something%, but there are those who are getting sort of 40 or 50%, that we need to be getting 60% to open up STEM careers. And then there's everyone in the middle, sort of around the more in that gray zone of, like, should they take maths or math literacy? And it's not always clear. And there we need better selection between maths literacy and technical maths. But by getting that subject choice right, that doesn't lead to more STEM careers. The STEM careers is more about the high level achievements. So it's about, I think we just need to be careful of the logic of, if we want more STEM careers, we need more people to take maths. What we need is those who are already taking maths to do better in maths, I think. And then there's a different question, also important question, about the subject choices. That's a different question. I think I want to separate those questions. And then you also asked, sort of, how do we get to 50 to 60% participation in maths? Now, I would say that if the policy outcome that we desire, if there's a goal within the department where we feel that 50 to 60% is the right proportion to be taking maths, the ways to get there are either you just encourage more people to take maths and you just accept that you get there through high failure rates, which I don't think is a great option. I don't think it really solves a lot to have 60% of children taking maths, but 70% failure rates. Or you do some kind of curriculum change. So you say that we want about 50 to 60% taking the sort of the maths subject. So therefore we adjust things so that that becomes possible with an acceptable pass rate. Or a third one, which is I think the one that most of us would recommend, is you improve the quality of learning so that more children can take maths meaningfully. So I think it does. I think almost everyone would agree that that's probably the best way to go. And that's hard work. That's really hard work because proper teacher support, it requires quite high dosage types of support, which costs money. It requires state capacity. It's not easy. It's long term. So I think we have to do it, but it is really hard work to improve the quality of learning and teaching. And then the other question was, does the DB have a research-based guidance on how to choose between maths and maths lit? Probably not enough. So I mean, I put forward a specific proposal, which I'm keen to pilot. I think before we start issuing circulars and things, I actually would like to be part of piloting that sort of a proposal with some real maths education specialists, of which I'm not, to make sure that we look at the data to identify schools, but then we offer pedagogically sound advice for how schools should navigate things based on what we can see about those schools in the data. And that's why I say we should pilot. We should always be aware of these kinds of things, that you can have unintended consequences when you issue instructions about these kinds of choices and what needs to be done. But I think I would like us to move in that direction of sort of a more evidence-based form of support to schools in making those choices.
Just make one more comment on that point. Last one. It's just that, I mean, does anybody want to take a guess how many students leave school and go on to study mathematics at universities in the UK? 8,000 students. Only 8,000. It's not a lot. I mean, the population of London is like 50-something million. So 8,000 really isn't. And the vast majority of those, what do you think they go on to become? Maths teachers. And I promise you they earn less than my local electrician. So we also need to be careful that we don't buy into this myth that mathematics automatically leads to higher earning and a better future. It's not necessarily true. It depends, but now I'm only talking pure maths. I'm not talking people going into STEM-related courses. So, I am being a little bit provocative. But I also just think we need to just hold on to that sometimes, that my mother-in-law got a G for maths at school, and she's incredibly successful in her life. Okay, she's run her own business, etc. So maybe just to throw that in there too.
Perfect. Thank you very, very much. I will just read one of the questions from our online participants as well, and it's actually directed to you, Professor North. And that is, and it's aligned with what you just started saying as well. The question is, right, given sort of the philosophical differences between mathematics and mathematical literacy, right, is it possible actually for teachers who get taught in one area to actually teach the other? And secondly, and that sort of follows, what should universities actually then do to actually improve that situation? And maybe with that as the final comment, we will, after this comment, go for tea, because you all took a little bit longer with the body break, but we do actually will have the tea. Sorry, it's okay. We were supposed to actually come back at 45. Please, can we be back at 50 so that we can actually move into the other one as well, right? We will also give you a bit of time to talk to some of the keynote speakers, right? But also for us to keep sort of within the timeline of the seminar. So please, sorry, Mark, if you don't mind just responding, and after that, we will go for the tea break. Thank you.
So I'll keep my response short. Is it possible for teachers that have taught one area to teach another? Yes, it is. I mean, I'm a case in that. I was a mathematics teacher and I became a full proponent of mathematical literacy. I think it is harder to go the other way. I think if you've only been trained to teach mathematical literacy and therefore you focused on slightly lower levels of mathematics, I do think the mathematics is harder to move into. I think maths teachers find it quite hard to get their head around the fact that we're not teaching maths and mathematical literacy, and that we're teaching sort of application and contextual. But I do think it's possible for them to move. But like anything, it involves new learning and hard work. And it also involves an understanding that the subjects are different. So your outcomes are different, and therefore the way that you need to get to your outcomes are different. Sort of in terms of teacher training and what universities could be doing, again, I think the universities, for teacher training provided universities will be responding to what's happening in the classrooms and what's happening at an assessment level. You know, we don't like to believe this, but assessment does drive teaching, and it does drive, in some assessment drives teaching. So obviously if the assessments were sort of very, very contextualized, and focused on real life applications, then I'm sure that your teacher training would follow suit. So I think there's something around the fact that if we perhaps lessen the disconnect between the intended curriculum and sort of the assessed curriculum, and maybe the implemented curriculum, then you might find that sort of professional development and teacher education programs follow suit. But I also just want to sort of finish on this, because the gentleman earlier asked the question about, I can't quite remember what the question was, but it was Kotso, and he was asking about teacher training specifically for Maths Lit. How do you set an examination that involves contexts where the students don't know what context they're going to be assessed on? It's a massive problem, and whose context is most relevant? Okay? Just remember, I'm a white middle-aged man writing a curriculum for primarily black students living in underprivileged areas. Okay? There's bias built into the curriculum, and I know that. We know that. So there's something about setting aspirations, but there's also something about sometimes we use context that the student can't relate to, and therefore we're not actually preparing them for real life because they have no experience of those. And so from an assessment perspective, it's really, really, really hard to design a contextualized experiment or assessment where the students aren't disadvantaged because they don't understand the context. It's not there are no easy answers to any of these questions.
Thank you very much, and thank you. No, please continue. Please give our keynote speakers a hand. Perfect. As I mentioned, we are running just 5 minutes late, which for me as a German is already panic mode. Right? So can you please try and be back at 10:02, right? So that we can start at 10:02 with the next session. Thank you very much.
or consistency across universities' curricula. And the depth at which they engage with it also varies. But coming back to an important thing that we mentioned earlier on in the discussion, about the design and the implementation of the curriculum, but what about the assessment and the assessment practices? We find that the teaching and learning tasks are important, isn't it, to drive meaningful learning and to understand the various aspects that we want, either in mathematics or math literacy. But the assessment tasks, the alignment between the two is a disjunction, both in terms of depth, probing, of understanding, and cognitive demand and critical thinking, etc. They vary. And so that's a challenge to address and relook at. And fortunately, we made some recommendations that at that stage, Prof. Engelbrecht from the South African Maths Foundation was with us as well, Professor Mamaketi Fatati as well, and those recommendations are sitting somewhere, where we came to an agreement of what should be the bare minimum in any curriculum across an institution. And more important, for the other programs, also with the printed program, and those are with Mr. Tech, and Mr. Tech is yet to be released. And when that's released, then maybe it create a pathway and enable us to move forward with that in teacher education. But coming back to the other aspect of teacher education is that institutions that offer maths literacy and mathematics itself as separate streams, right? We find that in the selection and the target and the enrollment processes, preference is given to the mathematics students, and then we don't students coming into the maths literacy stream. And if you want good quality teachers, you need to ensure that they have the capacity. But also, from a development point of view, when we do that, they are able to grasp the necessary concepts. And I want to mention an important point and draw on Stephen Taylor, and I want to tease him a little bit. Earlier on, he showed a slide and he spoke about Capricorn and the highest lack achievement, etc. And I always say to my colleagues every year, good results in mathematics come from Limpopo. And I always say that is one of the reasons for that is there's good quality teacher education going on at the University of Limpopo that works with the community, you understand? And that's an impact, and that's why Capricorn has got such good results. I did live in Capricorn for 5 years. So I think what is important is the level of engagement and commitment in terms of empowering our teachers to go into, our teacher educators, to design authentic tasks, to model best teaching practices so that our teachers can go out in the schools and do the necessary in terms of what the curriculum requires for us for maths literacy and mathematics. I'll stop there.
No, you don't have to stop. I could see all the people from Limpopo. They were the ones who were smiling. I would love to talk to you more about, you did this under USAF, but what's the role of quality assurance and the CHE? But we're not going to go. Come to you, Gladys, because your job as CES for Maths Lit is huge. But what we want to find out from you, if you've got any insight into where teachers struggle. So I'm trying to build that in terms of what Rajan has said, in terms of this preparation, there's challenges in the system. Where do you see teachers struggling with maths literacy?
Oh, thank you, Mary, and good afternoon. Talking about the struggles that teachers are facing, let me start from the fact that mathematical literacy is a highly enrolled subject. And at the school, it's not a good word, but let me use it. Learners who are stigmatized, learners who are said to be doing a subject with a surname. And that does not come only from the school community. It also even goes beyond that. Let me give you this example. Mathematical literacy in our sector is in the MST Directorate, but is not treated as an MST subject at all. In terms of support, even at schools, in terms of teacher development. I remember when I came to DBE in 2021, that was my first year. 2022, I went to teacher development to request for teacher development. I had profiled my district and realized that there is need for teacher development. Then I approached the director for teacher development to be developed. What he said to me is that we cannot give you this opportunity because mathematical literacy is number one, not a skill subject. Number two is performing. And then I said to him, then the subject is not performing because we have got 72, we're at 74.6 that year. And then I gave him a breakdown of the passes in terms of the performance. And I said to him, you're looking at the overall, the quantity, not the quality of the performance. What I'm looking for is the quantity, is the quality, not the quantity. Then he said to me, convince me that indeed you need this support. Then I convinced him. And then he gave us a platform to train educators. The following year, we moved from 74.6 to 85.7 in terms of performance. And during our trainings, he was attending the teacher development trainings. And then he said to me, yo, now I'm converted, I'm a convert. I used to think that mathematical literacy is about 1 + 1 = 2. Now I understand what mathematical literacy is about. So that is one of the challenges that we are facing as teachers. I'm also a teacher, as teachers in the sector, to say that the subject itself has got a stigma that is attached to it. The learners also have got a stigma. If we talk about learners who are not cooperating in schools, those are the learners who are doing mathematical literacy, because already they have been rejected from the school. Even when they want to do mathematics, they are told, no, you are not fit to do the subject, whether you belong to that class, to an extent that mathematical literacy classrooms are overcrowded. You find that in a school, I was even talking to the whole earlier on, you find that in a school that is having an enrollment of 500 in the FET. FET, I'm talking about will have from across the FET, 56 learners doing mathematics. I mean 8 in grade 12, 20 in grade 11, and 30 in grade 10. And where does the rest of the population go? It goes to mathematical literacy, because technical mathematics is not for all the schools, but it's for technical schools only. So, and I also think that another challenge is that teachers who are teaching mathematical literacy, most of them are not qualified to teach the subject. Most of them that are, especially in the lower grades, those who are no longer relevant to the staff establishment of the school, those are the teachers who are given the subject. The teachers who are additional to the staff establishment due to maybe the decrease in the enrollment of the school. Maybe the school used to offer PCM subjects. Now the subjects are no longer popular. That particular teacher, in order to be kept at the school, is given mathematical literacy to teach. So, and even in terms of support, I talked about a few learners enrolled in mathematics, But for that particular teacher will be given priority. I mean, resourcing teachers has nothing to do with a subject. If there are 20 teachers at the school, if those teachers had to get laptops, I think all of them should be prioritized. But the teachers in mathematical literacy, they don't even get a simple laptop. They don't even get, learners don't even have calculators that they can use in the classroom. You go to the exam, they don't even know how to use a calculator. That is why most learners are discouraged. They are not motivated. I'm telling you, even if we have intervention activities or intervention classes, you go there, you find that 100% in mathematics attendance, but 0% or 20% in mathematical literacy. So I think in order to improve that, what we need to do is to change the perspective about mathematical literacy. The narrative that is currently in is that mathematical literacy should be done by learners who are not good in mathematics or who are not who are failing mathematics. And that is what is happening even in most schools, especially the former Model C schools, when they realize that this particular learner is not getting 40% in mathematics. They channel them regardless of their subject choices. That is why there will have to be a lot of concessions coming from Me Okubanjo there. Every year they do concessions in order to cater for learners who live to do mathematics in mathematical literacy in grade 12. So just because of the subject choices, they now have to make sure that that learner is resulted because the provisos do not cater for learners who do mathematical literacy and physical sciences. So I can talk about the struggles of mathematical literacy teachers until the following day. Thank you.
Thank you. Thank you so much, Gladys. And I just noticed in your bio that you've been in education nearly 30 years.
89 years to be exact. Yes.
Just now we have it.
And I've been in all the posts in, I did not move from a PS1 to principal. No, I climbed all the ranks.
You can learn about from you. So we're going to take, yeah, thank you. So then, I think that Gladys has given us a convincing set of people that are rejects, stigmatized, etc. Now, your work, working with real learners on the ground, and you mostly are in Diepsloot.
No, we started in Diepsloot. We're now across the country.
Ah, okay, good. So if you can just tell us what you think can be done in terms of the students' sense of deficit and how that can be changed, because they know that they're weak, they know that they're stigmatized. Thank you.
Yeah, I mean, so I mean, listen to a lot of what was said this morning, and I think that something Stephen Taylor said really resonated for me, and it's something that we've seen because I work in primary, high school, and all the way through, is that what we're seeing, part of the problem, a huge amount of the problem we're seeing starts in the primary school. And what we're seeing is extremely proceduralized teaching of mathematics in primary school. So learners emerge from primary school with very little conceptual understanding. But even worse, they emerge not having mastered the procedures of primary school. So right from the start of grade 8 and 9, start of high school, what we're seeing are learners in maths who are needing to do 5 plus 2 by literally counting with their fingers, doing 8 times 9 by putting little stripes, you know, and then counting them all up. And this is happening at our high schools. So straight away, that loss of self-esteem in terms of your ability to do maths is starting right from the beginning of grade 8, before you've even made the choice for maths or maths lit, because the majority of our kids are sitting in a class in which they're not understanding a single word of what is being said to them in a mathematics class. And then our grade 8 and 9 curriculum is so stuffed, and all the work on whole number is done in the first 3 weeks of grade 8, which is the time at which schools are still trying to sort out their admissions and their timetables and whatever. And so the learners are suddenly thrown into algebra at a point where they can't add. So what we're seeing in terms of that self-esteem problem is from way back when. And unless we challenge that and start to find a way to, in grade 8 and 9, really, well, in primary school and then in grade 8 and 9, really have some solid work with our learners on developing their number sense, developing their ability to work with number, their fluency in core number, knowing their times tables to be as dull as anything. We're not actually going to get kids who can move into maths, but even worse, we're not getting kids who can move into maths literacy and deal with it at the level of the problem solving and the modeling that Mark was talking about. Because if you're still trying to count on your fingers, you might pass maths literacy, but with 30%, because all you're going to do is pick off the bottom things. And that's what we're seeing happening. So I kind of want to keep pushing that argument back to, we need to see what's happening in our grade 8s and 9s. So just like your maths literacy teachers are the sort of stepchildren of the teachers in high school, so are your grade 8, 9 teachers. Very few kind of the top maths teachers are put into teaching grade 12 maths. They're not put into teaching grade 8 and 9. And in fact, at grade 8 and 9, and I would argue for maths literacy, you need a high level of skill, because you actually need to understand how to deal with some of that primary level maths and developing number concepts, as well as understanding where it's going to in terms of higher level mathematics. And then if you combine maths literacy requirements, you, as a teacher, you would need to understand how to do modeling really well. And you would need to have a very broad general knowledge, so you understand financial literacy, health, ability, etc., etc. So the requirements for our maths literacy teachers and our grade 8, 9 teachers should be incredibly high. And instead, what we're doing is we're fobbing off those levels to teachers who don't have the skills to do it. And if I think about grade 8 and 9, there's a huge amount we need to do. How do you get learners fluent in their times tables? I bet you half the high school teachers have not a clue on where to start with that. How do we develop number sense? I don't think our grade 8 and 9 teachers know that, but they need to know that as well as how to introduce algebra. So I guess for me, that's my sort of strongest message here. If we want to have a maths lit curriculum and outcome that does something profound and really allows our learners out at the other end to deal quantitatively with their world, they need to have the good preparation in grade 8 and 9 as much as any maths student needs to as well. Otherwise, we're always going to have this kind of 30% maths literacy thing that no one is going to take seriously. So that's my argument.
Yeah. Fantastic. Thank you so much. I'm going to go to Tabo now. And Tabo, he's a program manager for financial education at the foundation. And he's got experience in business, in education, and he's busy doing a PhD. So we all say strength to your arm for that. So Tabo, what I want to ask you is I'm going to ask you two things. One, your sense from workplace experience, are there competencies that come with maths lit that are undervalued in the business environment that are really relevant to practice? And then I'm throwing you another one. I love the idea that's come up a few times today, that maths literacy is a misnomer. It gives I'm sorry to the architects, but it gives a sense of literacy as a low-level skill, not a high-level competence, which is what I understand from Mark. So
Do you think, first of all, are there competencies within maths literacy that really are undervalued in terms of their application to the practice, the work environment? And do you think a change of the name might shift perceptions?
Sure. Firstly, thanks, Prof. And I must indicate my boss is here, so I better be there. So whatever I say, please pardon me. But before I answer your questions, perhaps I need to introduce myself and say I am not just an employee at Old Mutual. I'm also a parent. And I like grounding this because there's also a parental issue around mathematics and mathematical literacy, right? In my case, I have 3 kids. The one is 24, the other one is 25, the other one is 23. And yes, you can ask their mother, I have nothing to do with that. But here's my story. Thabo is the older one, just finished his IT qualification. He decided he's bored. He went into motor mechanic. So we knew fairly early where Lethabo's kind of headspace is, because I think at the age of 9, 10, he wanted to become a hepatologist. But like a typical parent, I said, yes, yes. And I took a phone and I went to the bathroom to check what is a hepatologist. But I knew that whatever happens, he's going to end up in one way or the other in the science stream. So I was fairly comfortable with that. I'm going to skip Chofas. Chofas is the middle one. And I'm going to go to Tadohas. Tadohas is very skilled in singing, dancing, artwork, very, very competent in that. And when I asked at an earlier age what she wanted, and she had 2 choices, really. She wanted to go into drama, and she also wanted to go into architectural sciences. And said, look, I'm going to start with drama. If it doesn't work out, I'll go into. And at that point, we had to make a decision that she will end up doing mathematics. So everything else failing, she will rely on mathematics. But she ended up, she's just completed her honors in drama with pure maths and a distinction in that. So we come to Chofas. Chofas is a very special child. You can't pay Chofas enough money to make him love school. Chofas in school, just don't do it. And at a very early age, I wanted to find out, a typical parent, what do you want to be? And I asked all 3 of them. And he was the last one to respond. And his response was, whatever you're doing, I'm going to own the business that employs them. Right, he's 24. He owns 3 companies. Why that is important is because at some point, Chofat was battling with mathematics. And he was depressed and pulling hard. And eventually we decided, no, stop, take him out of this. And he completed his matric, and he went into this design world, completed his qualification in design, and started in the business venture without pure maths. Of the 3, he's the most successful. Why? He's the happier of the 3. So here's the challenge with the parental part of it, is you gotta understand that it's not a binary decision. It's not an either-or decision. It's what is suitable for that particular child at that particular moment, and what impact will it have overall in his well-being. To me, education is about the well-being. Yes, Prof, respectfully, Doc, it might be about qualifications. To me, it's about happiness. Because you might be a professor and be miserable. What? Left the thing. Sorry, Prof. It's got nothing to do with the weather system where you come from. You're welcome to spend another 2 days here. You'll be okay. But here's the thing. At the same time that I'm a parent, I'm also an employee at Old Mutual. And the question, Prof, is, let me also tell another story. Old Mutual employs over 17,000 people. Right, in South Africa, there's less than 60 black female actuaries. 60, yes, 60. In the entire South Africa. 3 of them are my bosses. You need actuaries to calculate risk if you're working in a complex system such as Old Mutual. So you do need people with higher order thinking who knows how to work with numbers. You know, you need people to calculate risk, to create that funeral cover, that life cover, that policy. You need people with mathematics to calculate how much we need to risk in terms of credit and debt. You do need that. And you also need Tabo to go read a contract and write a contract. So we need lawyers. Because if you have those guys that can work with numbers but can't write a legal contract, you're doomed. So from an old mutual point of view, it is also not a binary decision. Yes, we do need people with STEM, and yes, we do need people with high skills in terms of mathematics. But you also need a Tabo, right? You need somebody who can actually read and write a contract. Oh yes, you do need cleaners also. Because the system will not function if you don't have a plumber. The system will not function if you have nobody Old Mutual, 108 years old, because we are good in marketing. I don't need a grade in maths to be a good marketer. It's got nothing to do with my boss. By the way, the chief marketing officer at Old Mutual is an engineer, it's a qualified engineer. Yes, he needed maths to do that, but his job is to craft a message that says you can buy from us. So it's not as easy. It's not a binary thing, because it's got to touch all of those things, but it has a lot to do with the decisions that we make, firstly as parents, secondly as employees, and thirdly as sponsors. And as a sponsor, get in trouble for this because I need to consistently write business cases. Why? Because if you talk about the stigmatization, it also applies in corporates. Because if you go to corporates and say, look, Khotso, I need X amount of, yes, you're going to write a thesis just to get 10,000 out of it. And you have to explain why. Why can't we sponsor maths? Why must we sponsor maths? So it does apply. But fortunately, when you have people in the system who are saying we understand that almost a third of the people will be in the mathematical literacy space, and we do need lawyers. And yes, you do need marketers. Therefore, we do need to spend some sort of investment in that particular space. That's why we spend money in teacher development. That's why we spend money in content development. That's why we spend the money in a workbook. Because we recognize that if we don't do that as Old Mutual, then we're not going anywhere. The last bit is, yes, I agree with you fully. Perhaps it's got something to do with the name. Maybe we should call it, I don't know, Tabo literacy. Find another name. No, because yes, that also creates some sort of a link between the two that's not necessary. But the last thing, Prof. Danaban, here is where South Africa is in terms of financial literacy, right? One of these studies, I think it was the Blue Bank. I don't mention the name because I might be misrepresenting them. But they said to us, the typical middle class in South Africa is broke 3 days after payday. 1, 2, 3, broke. 3 days. 3 days after payday, you broke. Right? 2/3 of you spent more than you earn on debt. Right. Out of the current working population, 94% of you are going to join me at SASA. Only 6% of you will retire comfortably. When we talk to people around financial education, all of them say to us, I wish you could have told me this earlier. That is where mathematical literacy comes in. Yeah. We want to talk to you earlier so that then we can, at the later stage, not have that conversation. Let me close it there for now, Professor.
Fantastic. So I've got an easier job keeping time because I can cut at any point. So I'm not going to try and get through all the questions we discussed. So I'm throwing you things. Now, this question is for the audience. And when I ask my next question, which I'm going to ask Rajan and Gladys, I want you to think about this question, and I'm going to come to you after this for you to make some contributions. And the question that I want to ask the audience is, what are the assumptions about maths literacy that we need to really challenge in the discourse if we're going to make progress. So I'm just going to take 5 or 6 hands and see if the panel wants to add. I'm coming to you with that, but not now. You can start on notice, but I'm not looking. So now, Gretchen and Gladys, what I want to ask you is the issue of stratification has been brought in. You've said we don't need a Taba, we need a Mary, but we also need high-level maths people. What I want to ask Gretchen and Gladys is, what do you think is the impact of existing socioeconomic inequalities on performance prediction in both maths and maths lit? You want to go, Richard, and maybe Gladys?
So I think that's an important question. I mean, firstly, when I used to take a question of the textbooks and the material that's available for teacher education and for learners in school as well, for teachers to use, right? I've been a subject advisor, I've been a school teacher, and I've been a university lecturer. My experience and observation of going to the classrooms is the teacher will take that textbook and believe it's the gospel truth and will use those examples to exemplify that which he wants to teach, the concept, etc., even if it's incorrect. I think one of the important things that we must do is to quality assure that material, that it aligns with the design and the intentions of our curriculum. If we don't do that, then we will find cases of maths literacy which are supposed to invoke modeling in real context not happening. The kinds of examples that we draw into the textbook, which was shown this morning about, for example, the tariff one. I mean, that's the kind of material that we want. Then what actually happens is it gets reduced to mathematics. So that is the one. And by coming back to the textbooks and the resources, is that parents who can afford the buying of those materials, the extra support material, sending their learners to particular support classes over weekends, etc., has an impact on the final output of exactly what actually happens. Somebody spoke about in certain provinces or in certain sections, there's a parallel schooling system running whilst the main schooling system is running. And so the question is, who's the advantage and who's benefiting from that? And that is why we need to normalize that through the curriculum that must provide the minimum that is quality assured at the school level. And that is where human resourcing is important. That is where the infrastructure, both in terms of the space in which our learners work and our teachers work, as well as the technological tools and all the different kinds of resources that you want to access mathematics literacy and mathematics. But I think going further to that, coming back to the question is that when you get into an environment, and particularly looking at and the placement of teachers, although it's a department's responsibility, but if you canvass the environment of which teacher is in the quintile 1 schools and quintile 2 schools, you'll find some discrepancies, and some are very serious discrepancies. That you have in some situations a teacher, as my colleague mentioned, because the principal sees that he's got maths literacy, you can do that, Or you have no teaching load, and the post-provisioning norm is like this. Okay, but we're going to keep you must teach maths, or else we're going to move you on. All of those things have an impact in terms of exactly what actually happens in the teaching and learning environment in the classroom. You have to have a teacher that understands the pedagogy behind the teaching of mathematics and the teaching of maths literacy. There's different pedagogical approaches. How do you facilitate inquiry-based learning in the maths literacy class? How do you make informed decisions? Now, all of that comes and is linked to the placement of teachers, and that is also linked to the socioeconomic status of how schools are around the country. I will come back and respond to more, but let me give Gladys a chance.
Thank you. Let me say that in terms of the socio-economic factors affecting both maths and maths lit, it's most of our Black communities, let me say that, are impoverished. That is why more than 80% of the learners who are doing mathematical literacy are Black learners. Last year, we had, I'm talking about full-time candidates, 477,160 learners wrote the NCS. And then we managed to pass 411 and 1,311. Which means only 65,849 failed. It's not only because that is, each one of them represent a household. So for them, it's 100% fail. So, but the learners who are doing mathematical literacy in our Black communities are 428,867, which means that this their socio-economic status has got an impact in the choice of their subject. He was talking about quintile 1, 2, 3 schools having learners who are coming from low or poor communities. And in terms of even resourcing those learners, it's very difficult. Even for them to have those extra intervention classes that can make them to be recognized as performing, is difficult to get them. Let me say, I was once as a GET manager in a rural community, Ekamamito. So in that, always I will fight with colleagues, especially union social partners, to say, I want to see the learners at Umajayeni performing like the learners at Flora Park in Zanin. Because in our mind, it is learners who are in rural communities are not supposed to perform. Hence, even the commitment that is there is not the same that is in the former model schools. It's hardly to see learners in town not being in class, but it's common for us to see learners in townships or in rural places or communities loitering the streets during school hours. That is where we have to make education a societal issue. It's only that it's difficult these days to find a learner in the street and carry that learner to school. If it was the olden days, we will carry them back to school. Yeah, I was a principal at one stage. After trial examinations, learners will not come to school. I remember one day I even took my car and went to the village to collect the learners to come to school. And I found one learner cooking. When she saw my car, she ran into the house. And then I followed her inside her house and said, come. Perfect said, no, let's go. And then went to school together. Because for me, if she did not go to school after trial, then it means that she's doomed. She will not pass. Because we know that they don't even read or study at home because of the activities that are there in their communities. We have got a lot of talents. Yes, they bring money, revenue to the owners, but they give distractions to the community. So what I want to say is that what we need to do is to resource schools. Make sure that there is a textbook or resources for each and every learner. As mathematical literacy, as I said initially, we are trying by all means to make sure that we provide for the learners. Most of the times when we look at the diagnostic report, which is out now, we try to single out the recommendations that have been made there in the diagnostic report and try to intervene. At one stage, there was this a finding that learners are not good with definitions. There are a lot of definitions in mathematical literacy, and most of them are supposed to be defined according to the context that is given, which means that the learners will need to understand the language and also the definition, the common definition, and also applying it into the context that is given. So in order to make sure that we realize that, we developed a technology booklet and we share it among the learners. Now we realize that the teachers that are teaching grade 10, I've already said that, are not mathematical literacy teachers, and they cannot follow textbook method, because remember that mathematical literacy is a context-based subject. We are not doing what Professor North said, solving x squared minus x minus 2. The context change every day. If in 2015 that was at 14%, that is no longer at 14%, which means the book that was written is no longer relevant. Then petrol was cheaper. Now inflation was at this point. Now it has changed. So we try to make sure that the context that we give is relevant. It's real life context. And if we have to take it to the market, if the learners that did mathematical literacy can be in companies, it means that they can be able to assist a particular company with reading out what their financial documents, like your budget, analyzing them. Most of you here, you pay money for your annual returns, but in mathematical literacy, we can do that because tax is one of the personal income tax is one of the topics. Most of you here have got a pile of bricks, a load of tiles, a load of cement in your homes because you did not do the calculation before you started building. You find that builder who came and said, no, this house needs 20,000 bricks and 500 loads of cement. And then you bought that. And then after building, you have got piles and piles of cement because you did not do mathematical literacy. So mathematical literacy is very, very important in our day-to-day lives. If you're doing mathematical literacy, you cannot be fine on the road carrying 5 liters of petrol, because before you undertake that journey, you will have calculated how much you need to travel from here to a particular place. Looking at your car capacity, and also the distance that you are going to travel. So we need I'm not talking. I'm not.
No, you are a good proponent of maths literacy. Thank you so much. I'm going to take some additions on this one. The socioeconomic kind of context, Rajan, and definitely Lynn. I'm not sure if you also want to come in on that one quick. Then I'm coming to you for your questions, comment.
I want to talk about the technological tool, the basic calculator that one ought to have for math literacy and mathematics. If you look and scan the environment across the sector, that you find different calculators are used in different schools. Some learners don't have a calculator, so they will borrow the calculator in the classroom, or else in some classroom, the teacher will say, this is the answer, and the student doesn't know how to find the answer. You understand? And let me give you a real example. In the mathematics paper, for example, in 1 year, we asked the student for 2 marks, 3 marks, calculate the standard deviation and correlation coefficient. And you use your calculator, it'll take you maximum 2 minutes. And you only have to use 2 lines to write your answer. For the poor learners did not use a calculator. They did all the calculations for 10 pages. And the answer was wrong in some cases. And then the student wasted his time. So it's a matter of people not having the calculators. And something that we need to look at very seriously if we are setting questions based on the calculator in the examination. The other thing that's really experienced, we come to the Western Cape, for example, you have a school, and you have the drug addicts outside, and the gun is being fired and people being shot, and learners have to leave the school or not able to go to school or the taxi on strike. So the learning absenteeism is high, they're not able to attend classes, they miss out on chunks of work, and that's the only opportunity they get to listen to something. But when they go home, there's no home, you understand? There's no environment to do work. And that's a reality that we face. But when we set the examination paper, we say a grade 12 learner is looked through the following lens. He has a classroom, he has a stable home environment, he's able to go to school, he's got all the resources and a good teacher in the classroom and a classroom. But that's not so across the country. It's something that we need to look at. I think of the other one, I will leave my care.
So I just had quite a small point around the socioeconomic thing, though. One thing I've noticed in a lot of the schools I work in, which generally tend to be quintile 1, 2, 3 schools, is a very limited subject choice, even in really huge schools. So in a big school, we will see that you've got 2 options to take maths. You're either in the physics stream or you're in the accountancy stream. So you have to do maths, physics, life sciences and geography, or you have to do maths, accountancy, economics, and potentially business study or CAT. That means that if you then end up in grade 10 or 11 struggling with your physics, you have to switch to maths literacy at that point. And I think that that is happening quite a lot. There is no option for doing maths, history, geography, and life sciences in a number of our schools, which certainly in the quintile 5 schools I've worked in, that's no problem, right? There is a much larger degree. So I think that that might be something that we need to look at, because what we're seeing, I think, in a number of our schools is learners being moved into maths literacy at a late stage because they're struggling with the other high demand subjects that go with it. And that means that they're unlikely to get anything other than a kind of low results for maths literacy. And then the other point that I think that we need to do a little bit of investigation of, which I found quite interesting, is if you look at the IEB performance in maths literacy, and this is kind of taking IEB as clearly you've got very functional, well-resourced schools and well-advantaged learners who are going there. You're getting close to 50% distinction rate for maths literacy in those schools, and an average mark of in the 70s somewhere. So you're getting a very, very different maths literacy perspective at advantaged schools. What does that mean? Because what we're talking about in our schools is a kind of 3% maximum distinction rate and an average mark somewhere in the 30s or 40s. So what does that tell us? And I mean, I can't answer the question. I don't know, but it's something that's been playing in my mind. What does it tell us about maths literacy and what we might need to do differently to do things? And then my tiny little point I wanted to make around the naming of maths literacy, I don't think it's going to make any difference to rename it if it's still you make a choice between maths and maths literacy. You can call it what you want. If it's a choice between maths and maths literacy, and my argument has always been that I think what the content of maths literacy should be in life orientation and for all learners.
I'm tempted to start with that because that's one of the common themes that we pick up when we're on the ground. My apologies. That there's so many elements that are sitting in mathematical literacy that should be taught across the board. That's one of the things, but I'm not there. I'm going to respond to the SED part. Prof, yes, like I said, the old mutual system is a very complex system. We do actually have a fund in the SED, right? Socio-economic development funding. So we do have a view, and we are as South African, as African as we can be, because we don't service just the Sentin market. Yes, we do service the markets in Nometo. In fact, it reminds me, Lungi, my colleague is here. There's one of the events that she was funding in Malamulele. And it was supposed to be very simple, but one of the things that she realized when we get there is the lack of school uniform. We were not there for that. We're there for something else. And as we're sitting outside, my boss is also here, Jose, realized that the program that we run in Learn Think Do requires people to have connectivity. But the schools that we were in did not even have basic computing. So we went in there. Yes, the SED element, the social economic, it does have a factor. In fact, let me throw one term at you, Prof. It's called poverty premium, where the poor people pay extra for the access to what we normally would have. So I walk probably 100 meters to an ATM. If you go to the Eastern Cape, you take 2 taxis before you get to the. So yes, even in education, that also applies. Because it's easier for me to walk around and go to extra classes because it's just a walk. But for some kids, because they rely on school transportation, once it's 4 o'clock and you go home, you're done. So that poverty element does play a role. But I don't want us as South Africans, we are people of fears, we're different. We don't throw our hands in the air and say, yeah, well, it's the end of the world. We almost make a plan. We make a plan, we figure it out, right? Because if you look at the kids that pass from Mbili, if you look at the kids that pass from rural areas, I'm a product of Perukulu High School in Leboa. We do have the towers out there. We just cannot afford, particularly from a private sector point of view, we can't afford to just fund Sentin and Soweto. We have to go into the rural areas. We have to go to Tutuha in Butterworth. We have to go into Mamawolo in Limpopo. We have to go to Tabanchu. We have to go in serious in the Western Cape because there are rural areas in the Western Cape. So yes, it is relevant, but we can't sit it out. We have to be in there to sort it out.
Very good. Thank you so much. So I just want to give you a sense of where we're going with time. Okay. We've got half an hour now before we hand over for closure. I want to suggest that what we do is just take some contributions on the task I gave you, which is what are the assumptions we need to challenge. And I want to request that they're not speeches, but slogans, campaign headings. Somebody else must now set up the implementation plan. We don't want to hear it today. What are the key things, the key assumptions that we've got to challenge in the public debate? Okay, so I'm going to take a few hands. Then I'm going to come back to you, and I think that I've got a co-chair now, which is nice, for questions. So questions that you want to ask the brilliant panelists would be really wonderful. But I think we should also allow some questions if they need to bring in Mark and Stephen, because they are still here. And that's what we'll do until 12:30, when you'll be very pleased to get lunch. Now, I don't know people's names, so I'm going to give you numbers and just tell us your name, not your whole bio. So number 1 with the glasses, number 2 behind, number 3, the slim lady with grayish hair, number 4 with glasses, number 5 with glasses. I'm only noting the glasses. 6, 7, 8. Just quickly. All right, number 1, you.
Assumptions that we need to challenge in the public debate. I think some of the issues that have been raised by the keynote speakers, others have also been raised by our panelists. And I will take a cue from the responding to your question. And one that came out a lot, especially through Tabo, that we should not make the issue of maths a binary choice. And that links to the very first input that was made when we were asked to pose clarity-seeking questions. That perhaps the problem is in the name, mathematical literacy, because the first time there says mathematical. And we seem to be reinforcing this tension between mathematics and mathematical. And I can also give one example from today. I mean, you only have to look at the title of the presentation or the seminar, bridging the divide and taking the mathematics basis, mathematical literacy. So the basis in itself creates that tension. And as professionals, as academics, as society, we seem to be advancing this tension. So maybe then, because Mayor Kudiga is an expert in as far as Department of Education is concerned on mathematical literacy, maybe she should think very deeply about this name change. I mean, other countries of the world, they call it numeracy, numerical literacy, and everything else. So let's go that direction.
Fantastic. Thank you very much. Number 2 is you. I'm going to try and be a bit strict with time, hey? Can we carry on talking at lunch? Number 2.
Good afternoon. Okay, I'm Swamimila from H course, and one of the assumptions that I feel like we should address is the chase for results. So learners are being pulled into pure maths because the assumption that they're intelligent, and those that are less intelligent are being pulled to maths literacy. And I'm one of the cohort that first wrote the matric maths literacy exam, and I was being pulled to pure maths because they assumed that I was intelligent, but I did quite well in maths literacy with a 95% pass. So then the question would be, how do we ensure then that educators support learners in their subject choices rather than pulling them to the subject choices that we think that they should be doing?
Excellent. Thank you. Number 3 is you.
Thank you. My name is Sandy Makoka. I am the council member for the Students College. I am the deputy chairperson of the audit and the ICT committee. I'm mentioning that because I am going to link to the last note that was made by Tabo, which touched my heart. It links to a topic that actually talks to me very well, that talks about the digital divide. And where we have a child that is sitting in the township who doesn't have access to technology, versus to a child who is sitting in an upmarket area who's got all access to all this technology. So we are actually living in a digital age. We are living in the world where we as custodians of the higher education, we are talking about the education in the classroom of tomorrow, today. And my question is, we are talking about the research methodologies. We are talking about upgrading the curriculum. We are talking about moving a child from maths because they cannot afford or they are deemed not to be able to pass maths in matric, and then they are moved to maths literacy. I am the parent of a child who's sitting at home today who has joined the statistics of 2026. She got 79% pass rate, and because she was doing maths literacy, she's sitting at home today. So my question is, while we are busy doing the research, what role are we actually putting in terms of like AI and technology in general to ensure that it acts as a catalyst in our classroom, as well as making sure that we are using this role of AI and technology in the transformation of our education, specifically in mathematics, to ensure that we use this to accumulate all the data analytics, the data that we need to understand the role, as well as aligning that to the skill of every individual in the classroom, as well as aligning it to the industry in general. Thank you.
Thank you very much. Number 4 is you. Oh, sorry, we'll do 4, 5. Yeah. No, you go, Susie.
Okay, thank you. Yes, I think I'm just going to give a slogan, which I think is the perception that we have, that maths is a career accelerator and maths that is a career find it around. I think that's the perception we must try and do away with, because that is what is going on. It looks like you do maths, you do maths, everything is shiny, but there are doctors sitting at home without a job.
Excellent. We make you the campaign manager. Now.
Aaron Tau from University of the Oaks. I think we need to move because we are over 30 something years into democracy. We need to move from the concept that we're still in the era of maths higher grade and maths standard grade. Because those days we could not perform well in maths higher grade. We just downgraded to maths standard grade. And mathematical literacy, I think, is a different animal altogether. For me, when I look at mathematical literacy, I look at a subject that it's tactile, it's visual. And if you go to the classroom, you find that it's textbook based. So we still assume that a learner, all learners in the classroom are auditor. So we just teach those learners. Those who are visual, those who are tactile are not accommodated. So we need to resolve mathematical literacy classrooms with relevant manipulatives so that at the end of the day, we can achieve what we need to achieve.
Thank you so much. Next hand. Yeah.
Good afternoon, Jerome Smith, Genesis Education. I just want us to do away with the assumption that we only have to start focusing on intervention in the FET phase. Intervention starts at the foundation phase. So once we do that, we will overcome a lot of difficulties. Thank you.
Fantastic. Thank you, Welcome, for helping. There's a hand or two here before we come to you. Thanks, Phil.
Thank you, Khotso Omchong. Mine is a quick one, maybe quite similar and potentially practical. The document and Mangudega, someone every 10 years or so keeps on whispering things to our parents. And that's where a lot of perceptions start. He first started, said, go learn English, and we went and we learned English and we found out that actually it's mother tongue. Then later you said mathematics and mathematics only, gateway subject, yara. Then we did that. We've got a responsibility to go back and set the record straight. So let's not just talk to ourselves. This policy conversation needs to go back to our parents as soon as possible.
So do you still have?
Okay. Good afternoon. I'm Kelly Matonsi, Subject Advisor for Maths Literacy at Johannesburg North District. So I know we're busy with assumptions, but let me just put it out there. When maths literacy was introduced, it was there for the 40% that was not taking maths. Why is it that the standard grade and higher grade that worked was removed? Because maths literacy was just a substitute that was coming in for the 40%.
Last one. And then we're going to take questions. That's you. Thank you.
Thank you. Stella Mufokens from Tshwane North District. Subject advisor for mathematics, senior base. Mine is to Dr. Taylor. I had wished to ask him what is his take regarding the high performance in grade 7 and the decline of performance in grade 8 and 9. I know that HSRC is busy doing a research around that, but I wanted his take on the matter. Thank you.
So, Stephen, you're not going to get your chance now. We'll give it to you just now. Thank you for all of those comments. I learned a lot from them. It's been really, really, really useful. We've got 15 minutes left for questions. Okay? So I want to also just say to Mark and Stephen, especially Mark, because you're visiting us, you might also have questions to everyone else. So feel free to put up your hand and ask a question. So let's take questions now. We've got the first one to Stephen. The second one I want to, before I take hands, I'm not going to look, is I want to pick up your question, the subject advisor from Joburg North. I can't remember your name, because you asking higher grade, standard grade, maths, lit, and I want to turn that into a question to Mark or anybody here who has the expertise. Is what I've learned today is that it's not the same as higher grade, standard grade. It's a different conceptual epistemological challenge. But we do need to answer that question about how does the current assessment framework differentiate performance? Because I think that's your question. A pass at 30% versus a pass at 70%, which in the old days may have been high grade, standard grade, is now a very different thing in terms of the qualification framework. That might be too detailed. Maybe people don't want to answer it, in which case we'll talk at lunch. Now, questions. One, let me do this side of the room first, and then it helps Volker and myself. So I've said one to you, 2, 3, 4, 5 quick questions, because otherwise we're not going to get to that side of the room. And then I'll feel bad. Okay, let's do this.
From TUT. Before I got to TUT, I worked with the English by the ones that they've been to.
It's not.
The best part we get right. Yes. I said I'm dynamic from TUT, but before I got to TUT, I was working with the ones I consider educators, the ones that failed from mainstream, and they are say so. Ed community, sorry. So most of these lands were that if you check the CET sector, there are no resources. There is nothing there. There is no teacher development, underqualified teachers, etc., etc. However, I have witnessed students moving from level 1 to level 7. A student who couldn't pass at mainstream, and I witnessed a lot of them. Some of them are actuaries, some of them are doctors, and etc., etc. So I wanted to check the possibility of reduction, work reduction, especially in mathematics. Because the reason they have passed, or maybe you witness this, I've never seen a teacher working tirelessly like a maths teacher. Come rain or sunshine, they are in class teaching Monday to Monday. So it means the workload is too much for the maths teachers. How about, if possible, the work reduction of mathematics? Certain content be taught at lower grades, and a certain extent, some of the work be assessed at the entrance so that we can strike a balance which he was calling for. I believe maths literacy is not simple. However, the workload as compared to mathematics is lesser. Hence, we have a higher pass rate in mathematics, and everyone believes mathematics literacy is simple. It's because of the workload in mathematics. While on the other hand, we cannot see the same. So maybe the work reduction in mathematics can help to strike a balance between the two. Thank you.
This one. So I'm just warning the panel how I'm going to handle this. Listen to all the questions. We'll try and get them all, then you'll respond to any you want. We're not going to answer all the questions, but that's the purpose of today. It's to provoke discussion. So you may ask a question which will just be the basis for discussion over lunch or with. So we'll take the questions, ask the panel to select what they want, and anything that you still want to say, because we're going to run out of time. And I'm sorry that I haven't managed time better, but it's your fault because you're so enthusiastic. Okay, let's go to the second person.
Hello, my name is Siabule Mugil. I'm a teacher at Hyde Park High School. So my question is, today it was clear that that numeracy, if learners don't have good foundation of numeracy, obviously they won't perform very well when they get to high school, right? But we also know that skills of reading also contribute towards that. So I wanted to find out if there's any data that actually shows how much illiteracy affects pass rates in both maths or maths lit and/or maths lit, and how much deficits in numeracy affects pass rates in both maths and maths lit. Thank you.
Yes.
Number 3.
Afternoon, esteemed delegates. My name is Kumbulan from Tutuzegani, it's a school in Gauteng. Firstly, I just want to applaud Umalusi for organizing this wonderful maths seminar. Really, it's very, 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 as a primary school mathematics teacher, I feel that the tension between the mathematics and mathematical literacy in South African schools is not about learners' capability, but about how deeply we build understanding from the early years. Although results in the foundation phase, as we did see the presentations, may seem strong, the real concern is whether we are developing solid conceptual foundations, mathematical language, and problem-solving skills that will support learners when mathematics becomes more abstract in the higher grades. Thank you.
Good afternoon. My name is Thandeka Tilana. I'm a teacher at Glenbrook High School. My first question will be when. Okay. Okay, it's fine. My understanding when maths literacy was started, I've studied it, I've done research on maths literacy, but at the beginning, the whole idea was it has to be done across, because the whole concept of literacy was everybody has to be literate in everyday's life. Where did we lose it? Why did it change and no longer become what it was intended from the beginning? Thank you.
I am aware that it was launched. How is it going? Can you speak there in both the
anything that you can give us in terms of
So we're going to take one floor, then I'm going to close my eyes and look on that slide. Quick ones. And then you think it's got 2 minutes. To choose whichever one you want. Say what you want to know, and the next one's to stay and I'm going to be straight because Emmanuel's coming here. It's got something to run. So I'm going to stay. So we're going to just be raising provocations. But a useless voice anyway. When I started training, they said, no, you'll never be a teacher. You haven't got a voice. So we're going to take 1 or 2 quick ones. Each of the panelists will get 2 minutes to choose any of the questions and to respond and to say anything. And I'm going to be standing up with my, if you don't finish on time. We have to finish at 3:30 because it's discourteous. 1:30. Sorry. So Volker, you do it.
I'm from the Western Cape, dean at the CPUT. You know, Prof. Govender described the situation under which our students come from. And what I like is what I think is Holler. Yes, Mr. Holler talked about, you know, in terms of financial literacy. I would like to urge your industry to assist us to have financial literacy from the beginning, brother, because I tell my students who come from very poor backgrounds, shootings, drugs, everything, that you keep 500 rand every month at 8% for 40 years. It's 1,600,000. And a lot of my children get shocked when I tell them that. So please, let's lobby government to do this, because that's another way of taking people out of poverty. Thank you.
So we can't take all the questions, eh? Volker's taking responsibility for who we do. No bribery here.
It's got one already. I don't know. Let's start this time.
And what you must remember is the conversation doesn't finish today. Hopefully you've been provoked to keep on thinking and reading and exploring. So those 2, and then you guys. Number 1 of the 2. Yeah.
Good day. So my name is Sean Naidu. I'm from Regional Education. And on top of that, I'm going to add that I'm also a manager of a tutoring company. Why is it at this point that tutors for mathematics are getting paid more than maths teachers? And they have influx of students for grade 10, 11, and 12. The second thing is all maths teachers, matric maths teachers, we know that the end of the exam has a certain format. Question 1 is algebra, question 2 is sequences of theories. It's been more than 10 years and the format has stayed the same, but our learners are not good. Why can't we use the IEP template, where the first 50% of the paper is level 1, level 2 questions, ensuring that the students get 50% for maths?
Last question from the audience, then I'm coming to the panel.
Good afternoon. My name is Tamitulu from Ikusasa Comprehensive School in Tembisa. When in varsity, I did become accounting. Now I'm busy with BSc Mathematics and Statistics. My question is this, maybe Mr. Tabu will answer. Aren't we missing the point here? Because one of the assumptions that we've been having is that you can only have a career in STEM, and that is the information that is propagated around. Now, one of the things that I've noticed, everyone says, congratulations on your matric, your matric results are very good. However, when you go to roads, Prof. Mabizela will say, you can't be a CA. But my point is, you don't need the angle at the center is twice the angle at the circumference in order to do discounted cash flow. You don't need sine squared plus cos s squared is equal to 1 for you to be a financial risk manager. You only need statistics. Because one of the things that I've discovered, maybe we are failing in the system, is that there's no justice that is done in grade 8 and 9. That is my main challenge. And I think Meslit, for instance, can be tailored to be a commercial mathematics because in the way it is structured, it could assist our learners. But not everyone can be an engineer. Trust me, I tried and it couldn't work well.
So I'm saying all other questions from the floor for lunch. But I'm now breaking my own rules. Because I think I saw Sisme Mabazela saying he wants to say something. It says we break all the rules. So over to you. Vice Chancellor, University of the 40.
I'm Sisme Mabazela. I work at Rhodes University.
Right, sorry.
I will resist the temptation of responding to the question. By the way, it's really important to understand that education serves more than just the utility value. So the mathematics that you learn, the algebra, geometry, you might not apply it every day, but what you have learned shapes the person that you are. So let's move away from this utilitarian view. The question that I wanted to ask is, what will it take to shift the public perception, which is negative, of mathematical literacy so that it fulfills its fundamental purpose? I served on the ministerial committee that recommended the establishment of mathematical literacy and mathematics. And I think Mark is right. The way that it has been taught has really done a huge disadvantage to a subject that has huge value in everyday life for every young person. The recommendation was that every learner should take mathematical literacy. There was no question about that. Thank you very much.
Thank you, Sisme. So I'm changing what I said I was going to do yet again, but we're trying to keep to time. You can't answer all these questions. You're going to keep on discussing the rest of your lives until you get an answer. You've all got maximum 45 seconds to say anything you want to say, and then Emmanuel will come and close. 45 seconds.
Yeah, I want to confirm that the mathematics enigma lies on the tension between the vertical growth of mathematics and the horizontal application in mathematics literacy. But given that, I want to come back to an important aspect that was raised about the papers, the high grade and the standing grade. I think the misconception arose because of what actually happened at that point in time in the discussions, and people had the idea that we're trying to find a subject to replace those. It was not that. The clear reason for the bringing of the math literacy was discussed this morning. I'm not going to repeat that. But what is important to note that why we can't equate the math literacy, etc., to high grade and standard grade is for the following reason. Mathematics, the ontology of the mathematics is abstract, formal justification, reasoning, and deduction and proof. Whereas in math literacy, it is contextual, it's applied, social constructive pedagogy from real life situations, social practices, and everyday quantitative engagements. And so the nature is different. So you can't equate the both, you understand? And we have to find a way of how we understand this and how we inform our parents and all the role plays in education and even teacher education institutions, which are the change agents.
And if you were to ask why we shifted and lost part, firstly, I would say blame teacher education.
I'm very quick. The story I just want to remind people of is let's really make sure that what we do up to grade 9 enables learners to either do maths literacy or mathematics in a way that is useful and productive in their lives.
Thank you. Mine is to say that we just need to change our mindset. Not looking at the hierarchy, because this is about hierarchy. Who is better than who? Mathematics and mathematical literacy, to echo what Mark said, are not distant cousins, but they are siblings, maybe twins. They need to inherit the same share in terms of their father's properties. So in order to improve and motivate teachers for mathematical literacy, we are even doing awards, National Mathematical Literacy Awards, in partnership with Old Mutual. We did that last year. We awarded schools that performed very well, and we are still going to do it this year.
About from the Old Mutual deliberately went out of its way to not only develop content in terms of mathematical literacy, but we've gone out of our way to actually engage in teacher development around the subject maths literacy. Go to omlearnthinkdo.com. There's content in all official languages, including Braille, that has been developed for mathematical literacy.
I'm sorry if I've been a bully, but we're more or less on time. I want to thank the panel. You were fabulous. And I think we're going to release you. I'm going to invite you, Matt.
No, not yet.
Yeah, Manu. Yeah.
Sorry.
No, sorry. Yeah.
Let me take over again.
Can I just say one thing? Sorry, Frauke. I just want to thank Umalusi, because Emmanuel and Matsia in particular have really been diligent in putting this together. They're not going to thank him.
Perfect. Thanks very much, Mary. I would like to ask Dr. Umalusi Banda, the executive manager of Umalusi, to actually deliver the vote of thanks.
Thank you very much, Program Director. Ladies and gentlemen, good afternoon. Just bear with me. Before I do the closing remarks, I just want to do some formalities and thank the panel members and the panelists. We have gifts for them. So if my colleagues can, and then thereafter I'll call the presenters so that we can also. Well, I thought we were ready. While, and also let me call the CEO so that he can hand over. While they're also welcome to the podium, CEO, and then Matthew will assist. I could identify with Tabo, what Tabo said earlier on. I have 3 boys, and one of my boys, it was a very tough decision for him to move from maths to maths lit. Believe me, we didn't have peace in the house because of our perception as well. But I'll stop there. It's the CEO and then. Oh, okay. Can I ask the panelists from Professor Metcalf first, and then the rest, so that you can follow? Yes, please just come down. Yes. Oh. Okay, please. Okay, so. Yeah.
Okay. Thank you very much. You chat very well.
Oh, thank you.
Thank you. Thank you.
Yeah.
Who's next?
Indra?
Oh, thank you very much. Thank you very much. And you're going to phone as well.
Yeah.
Thank you, sir. Thank you. Trying to good fish. Thank you, Mark. Thank you. Me?
It's been a while. Yeah. So nice to be back. Okay. Thanks.
Beautiful time. Well done. Thank you.
Right. Can I also ask our program director? Oh.
Okay, here we go. You also get.
And then Dr. Taylor and also from North.
Come. This toilet. Thank you. You have to come back for a campaign.
Okay, thank you, CEO, and thank you, colleagues. All right, before I go through my closing remarks, just bear with me to make one or two, statements or announcements, right? Now, the first one is that today's seminar is just one of the mathematics series that we're planning. So some of the issues that you raised, you will see how we can accommodate them in the seminars that are still to come, for mathematics in particular. The second thing that I want to mention is that Umalusi is a quality council, right? And one of our responsibility is to manage the sub-framework of qualifications. Now, the NSC is a qualification that falls under Umalusi's sub-framework. So in a way, we also have responsibility in the review of the qualifications. We have a say in it, but we also have a say in advising the minister. So some of the things that I've heard today is that we have to go back to the qualifications, to the qualification itself, and try maybe, to review the qualifications so that we don't have a choice between mathematical literacy and mathematics. It should not be a choice. And Professor Marizela is correct in that in their testing, they advised that mathematical literacy be offered to all the candidates. And Umalusi, it was also Umalusi's position for some time. But it was also Umalusi's position to say, let's change the name of mathematical literacy to quantitative techniques. I'm afraid not to say quantitative techniques, because then it has a SNA. We need to start thinking about it. But I think there are certain things that we can do. There are low-hanging fruits that we can do where for us, and they'll make a significant impact into the system. I'm glad that we have Ogubanjo here, and when we take the discussions outside, it will be easier to do that. And also, we also have this process that the DBE has embarked or is embarking on. They refer to it as a curriculum strengthening, of which mathematical literacy is one of them. While we acknowledge the purpose of the mathematical literacy, and I think what Professor North said to us, to say we can actually do better in terms of how we assess it and also in terms of how we teach it. And we have to see how we can incorporate that in our curriculum strengthening process. We don't have to lose that. So I'm glad that Priscilla is here. And then the other one is the elephant in the room, this master tech. All right, the master tech, which is in the domain of the department, because it lays down the standards or the minimum standards, minimum requirements for teacher preparation and that type of things. As Umalusi, we try to reach out to the department, but I think we are going to engage the department now seriously, because we understand the impact of that particular document. Right, now let me come to my prepared speech. Sorry. Right, let me first recognize the program director, the Professor Paul Kashua. Thank you very much, Prof. The members of the research forum under the leadership of Professor Mary Metcalf, Professor Mabizela, thank you very much, former boss of Umalusi. We also have heads of departments or faculties or deans of faculties. I saw Professor Mautu and also saw Professor Muji is also here. We also have, let me also acknowledge Koto Titoto, who is our person from Old Mutual. Colleagues from the Department of Basic Education, led by May Priscilla Okupanjo, there are many of them. I'm not sure if we have colleagues from the Department of Higher Education and Training. I must say they were invited, so we'll see how we take this matter forward in them. We also have representatives from universities. I need to acknowledge, and thank you very much. We have representatives from NGOs, industry partners. Ladies and gentlemen, good afternoon. Yes, let me start by thanking the research team of Umalusi under the leadership of Dr. Mohali for arranging this seminar. And also thank our partner, Old Mutual, for partnering with us in this seminar. Right. Ladies and gentlemen, from the opening remarks to the keynote presentations and panel discussions, this gathering has truly explored the complexity behind what we have called the mathematics enigma. We have reflected on the historical and international positioning of mathematical literacy. We've also interrogated the data, which provides insight, but also raises further questions. We have also had perspectives from research, classrooms, teacher preparation programs, the NGOs, and industry. Now, together, these contributions have deepened our understanding in terms of the two subjects. Now, one message that is very clear, or that emerged clearly, is that mathematics and mathematical literacy are different subjects, designed for different purposes. Right? Now, mathematics develops abstract reasoning and prepares learners for mathematically intensive fields such as engineering, actuarial sciences, and the physical sciences. While mathematical literacy equips learners with quantitative reasoning skills for informed citizenship, economic participation, and real-world decision-making. The reality is mathematical literacy, or the truth is mathematical literacy is not a diluted version of mathematics. Also, mathematical literacy is not inferior to mathematics. The two subjects are distinct pathways serving different but equally important purposes. Now, at the same time, we also need to acknowledge the concern that the number of learners taking mathematics, especially in the FET phase, remains low. And this concern is essentially valid. As a country striving for growth and innovation, we require strong mathematical capability. However, systemic challenges cannot be resolved by a simple directive. Policy statements alone do not produce qualified teachers, do not deepen the content knowledge or build the pedagogical confidence. So expanding access without strengthening capacity risks widening the gap between the policy intention and the classroom reality. Now, if we're serious about increasing participation and performance in mathematics, we must invest where it matters most in teacher development, particularly for teachers in the early phases, right? In the foundation phase, the intermediate phase, and also the senior phase. By the time learners, and I think this point was made by one of the delegates, by the time learners reach grade 10, their mathematical confidence and identity have largely been shaped. If foundations are weak in the earlier years or in the early years, interventions in the FET level will remain remedial rather than transformative. So early grade preparation or early teacher, for preparation, sustained in-service support, mentoring, and professional learning communities are not optional extras. They are a foundational investment. Now, today's discussions have also reminded us that there's no single stakeholder that can solve the enigma alone, right? This responsibility does not lie only with one department or with one university or one NGO or one professional body. It requires a collective action. And again, this is not a battle between mathematics and mathematical literacy, but it's a call for coherence, alignment, and also capacity. Now, as Umalusi, our responsibility is to safeguard standards, assure quality, and stimulate evidence-based dialogue about our qualifications. We approach this matter not from ideology, but from evidence and from our mandate to ensure that qualifications remain credible and also meaningful. Today's seminar has demonstrated the value of bringing research, policy, practice, and industry into one space, where data is interrogated, assumptions are tested, and solutions are considered carefully rather than simplistically. The mathematics enigma will not be solved in a single day, like today, but today we have clarified important issues, right? Reaffirmed the distinct purposes of the two subjects of mathematics and mathematical literacy, acknowledged systemic constraints, and recognized the need for a long-term collaborative effort. Now, as we depart, let us commit to three principles. One is clarity of purpose. The other one, which is also equally important, is the investment in teacher development, especially for the earlier phases, and also the collective action grounded in evidence. Now, if we hold to these principles, the enigma becomes less mysterious and more manageable. Lastly, allow me again, ladies and gentlemen, to thank each speaker, the panelists, the participant, and the organizers of this engagement or of this seminar. Your engagement reflects a shared commitment to strengthening mathematics education in the country. So let us continue this conversation beyond today. And Umalusi will probably also be leading in those conversations. Let's translate this dialogue into sustained action. I wish you safe travels and continued courage in your important work. Thank you very much. My understanding is also that lunch is served, and then the ushers will show us where to go from here. Thank you very much.
No, I'm doing the same as how we make it.
How are you doing this?
If you have a unit, so feeling the canal. Oh, okay, no point there. Stephen.